Good morning, Namaskar. Am I audible? Please confirm audio and video so that we can proceed for today's discussion. Good morning, everybody. Am I audible? I'm in arrangement. Actually, the subject which you were studying, that was, I think, ICT, Information and Communication Tools. But unfortunately, Saurabh sir lost his father, so he is not available. So in place of him, I am going to continue. Although I would be teaching a different subject, the subject which I teach from paper 1, that I would be discussing with you. So let's begin for the today's discussion. Good morning. Right. So all is okay. So let's proceed for the discussion. That in engineering services prelims there are 2 papers. Everyone may be knowing this. Still I am repeating it. Paper 1 and this paper 1 is common for all engineering branches. This is known as GS, although there is nothing like GS. The subjects which we study here, they are basically the engineering based subjects which we used to study in our engineering curriculum as a common syllabus. That's in first year, few subjects were in first year and few subjects were in every semester as a common subject for all the engineering branches. So those subjects we have to deal here. Sometimes a student ask me, sir, what should be our strategy to study general studies? There should not be any separate study. These all are the technical subjects. So as you study the technical ones, you have to proceed in the same manner for these subjects as well. So paper 1, this is common. And this paper is of 2 hours duration. There are 100 questions, and if the 100 questions, it means it is of 200 marks. So this is of 200 marks. Then the paper 2 is related with concerned branch. So paper 2, if you are electronics engineer, from electronics, if you are electrical, from electrical, if you mechanical, then mechanical or civil engineer. So paper 2 is from respective branch. That is popularly known as technical paper. So in this technical paper, there are 3 hours duration given to you, and there are 150 questions. So total weightage is 300 marks. Each question carries 2 marks. So in total, in prelims, you are given a paper for 500 marks, and out of 500 you need to target for 250 plus marks. Although the cutoff is generally lower than the 250, but 250 is considered to be the safest one, because 50% plus cutoff, 50% plus cutoff is rarely there. Dear Saurabh Prashant Jaite is writing this is English batch. It's not like English or English anything. I would be in mix of the language, and nothing is going to be asked in Hindi. They are not going to ask anything in Hindi. The whole paper is related with the general studies related topics, and those topics, the questions will be asked in English. They are not going to ask you ki material science kya hai batao beta. This kind of questions they are not going to ask. They are going to ask questions in English, and you should be aware and you should be learning it in English. Otherwise there would be problem to understand the things, right? Okay. So out of these 500 marks, you need to target for 250 plus marks. 150 plus you can target here. Sometimes if you are a good student, you can go for 170, 180 also. But beyond that 170 and 180, it is very difficult to score. So you need to go for remaining 80 to 100 marks from this paper. Paper 1. Although scoring in paper 1 is not very easy thing, because even MADESY is giving you very less time. We are giving you 200 to 250 hours to teach this. So it means we are not going to enter into very depth of the subjects. We will try to remain on the surface, so that 70-80% questions you can do. So even we are not targeting 100% here, so it's not practically possible to you to target for the 100% questions, but 70-80% questions you can do whatever we are teaching from that syllabus. So out of this syllabus, you see there are 10 topics, including math and reasoning as well. So UPSC has mentioned that 5% will be the minimum weightage and 15% will be the maximum weightage. Yani minimum you may be getting 5 questions from any subject, and maximum you may get 15 questions from any subject. They keep on doing the variation, but they have never violated this limit. The minimum questions I have seen from any subject, they are more than the 5, and maximum I have never seen beyond 15. So it means they are strictly following this rule, and if they are strictly following this rule, so you can take an average from any subject, you may be getting the 10 question on an average. 10 question means 20 marks. So this way you need to prepare for this topic. Now first of all, try to figure out at least 6 subjects for paper 1, so that more than 50 plus questions you have to attempt. Once you are well versed with 60 questions, 60% of the syllabus, then go for the remaining 2-3 subjects, whatever you can do in the limited time, go for preparation of those subjects. Out of these 10 topics, there is one subject that is known as Basics of Material Science, and today onwards I would be discussing that subject, Basics of Material Science. Basics of Material Science. This is the subject we have to discuss. Right. You see, my dear friends, material science is different thing. Even in this subject, EC, electrical and mechanical, they have material science in paper 2 also. But this material science is totally different. Whatever I would be teaching here, it is only for paper 1. Nothing will be for paper 2. The requirement of paper 2 cannot be fulfilled by the things which we cover in this class. यहाँ जो कुछ भी हम पढ़ेंगे वो स्पेशली पेपर 1 के लिए पढ़ रहे हैं, पेपर 2 के लिए कुछ भी नहीं पढ़ रहे हैं, right? So we would be focusing ourselves only for the paper 1. For EC and electrical students, there is a requirement of 20 plus more hours of teaching for paper 2. Along with this, whatever we study in paper 1 plus 20 plus more hours are required for paper 2 as well. That is taught by me, so they may be giving you separate time for the technical material science syllabus. For mechanical students, 30 hours are separately taught by some other faculty members. So please don't ask me ki whatever I am teaching here, is that sufficient for paper 2? No, it's not sufficient for paper 2. In this batch which we are going to study, that is especially for paper 1, not for paper 2. So we would be trying to focus ourselves only from the general studies point of view. Shivam Dubey and whosoever are writing me to teach in Hindi, they need to write MEDISI management, because when I was entering into the class, they told me to teach in English. So I am doing the job in any organization, and whatever mode they would be telling me to teach, even they say ki sir teach in Urdu, I will start speaking Urdu, right? So talk to the MEDISI management, and if they say to teach me in Hindi, I will continue in teaching Hindi. They will say ki teach in Sanskrit, I will start teaching in Sanskrit. If they will say teach me in English, I am teaching in English. So the management has informed me to teach in English. That's why I am continuing myself in English, right? If they will say me tomorrow onwards I have to teach in Arabic or French, I will learn Arabic and French and I will start teaching in Arabic and French. So please contact management. No need of writing here. It is totally waste of writing here, because I would be teaching whatever they have told me to teach. right? Let us come back to the problem. Basics of material science. This topic has very heavy weightage in last few years, although last year it was having least weightage. Last year there were only 6 questions from material science, before that there were 10 questions, and before that there were 14 and 15 questions. So earlier it were having very huge weightage, but last year it has very less weightage. Now there can be 2 inferences. First inference, you can see that last year the weightage was less, so maybe next year also weightage can be less. But the second inference can be last year the weightage was less, so this year they may overshoot the weightage. So anything may happen. That is the unpredictability related with the examination. So we cannot predict whether we will be getting 6 questions, 7 questions, or we would be getting 14 questions, 15 questions. So we need to prepare whether we get 6 questions or we get 14 questions, but we need to prepare. The beauty of the subject is that most of the questions are of static nature. There is nothing related with current affairs. Everything whatever we have to study here, that is of static nature. So those things can be memorized for the longer duration of time. So there is nothing dynamism in the subject. Everything is fixed. They are the definition based questions which we have to study. So beauty of the subject is if it is well read and well prepared, then you can score very well in this subject, right? What we have to study, first of all we have to study the introduction, right? This is not any chapter, it is just the introduction of subject. And then we will be going for the chapter 1. Chapter 1. Chapter 1 is atomic structure. And bonding, or you can write chemical bonding, whatever you like. Chapter 2 that we have to study, that is crystallography. Very important chapter. Last few years you may have got definitely 1 or 2 questions from this topic. Chapter 3 we have to study, that is electric properties of materials. Electric properties of materials. Electric properties of materials. Chapter 4, that is magnetic properties of materials. Magnetic properties of materials. This is chapter 4. Chapter 5, mechanical properties of materials. Mechanical properties of materials. Chapter 6, ceramics. Chapter 7, polymers. Chapter 8, composites. Chapter 9, phase diagram and alloys. These are the topics we have seen question from these topics in last 6 years. जो लोग हिंदी के बारे में लगातार लिख रहे हैं, मैं उनसे फिर से और उनको क्लियरली संबोधित करके उन्हीं लोगों को बोल रहा हूँ, बेटा मुझे हिंदी या अंग्रेजी बोलने में कोई दिक्कत नहीं। आई कैन स्पीक इन बोथ ऑफ द लैंग्वेजेस। मैं दोनों भाषाओं में बोल सकता हूँ और मैं दोनों में पढ़ा सकता हूँ और दोनों में पढ़ाता हूँ, ठीक है। पता नहीं तुम्हें क्यों बताया गया है कि हिंदी बैच है, मुझे क्यों बताया गया अंग्रेजी बैच है, हो सकता है कि कम्युनिकेशन गैप हुआ हो, ठीक है, कोई बात नहीं, आज की क्लास मैनेज करिए। वैसे भी पहली क्लास इंट्रोडक्टरी क्लास है, ठीक। सो पहली क्लास में बहुत कुछ ऐसा नहीं है कि हम कुछ आउट ऑफ द बॉक्स चीज़ें कर लेंगे, मोर और लेस इंट्रोडक्शन एंड बेसिक चीज़ों से जुड़ी हुई चीज़ें ही पढ़ाई करेंगे, ठीक। नेक्स्ट क्लास के लिए कॉन्टैक्ट टू द मेडिजी मैनेजमेंट बिफोर द नेक्स्ट क्लास एंड टेल हिम द टीचर इज टीचिंग इन इंग्लिश एंड ही इज टीचिंग टोटली इन इंग्लिश, राइट। डोंट से इवन कि ये भी मत कहिएगा कि एक दो शब्द भी हिंदी बोला, पूरा कहिएगा कि वो अंग्रेजी में पढ़ा रहे हैं, ठीक। सो दे विल कॉन्टैक्ट मी एंड दे विल से दैट कि सर नहीं, हिंदी में पढ़ाना है, कल से मैं शुद्ध परिष्कृत हिंदी में पढ़ाऊंगा आपको, आप बिल्कुल चिंता मत करिए। मुझे भाषा से रिलेटेड कोई भी प्रॉब्लम नहीं है, कोई भी समस्या नहीं है, मैं किसी भी भाषा में पढ़ा सकता हूँ। लेकिन मैं जब क्लास में इंटर करता हूँ तो मैं पूछता हूँ कि मुझे किस भाषा में पढ़ाना है, ठीक है। तो जब मैंने पूछा कि मुझे किस भाषा में पढ़ाना है तो मुझे ये बोला गया कि सर इंग्लिश में पढ़ाना है, दिस इज़ अ इंग्लिश बैच, राइट। अब हो सकता है कि इंग्लिश और हिंदी दोनों को मिक्स किया गया हो, तो इंग्लिश वालों को प्राथमिकता दी जा रही हो क्योंकि पेपर इंग्लिश में है, ठीक। तो यदि ऐसा है सो मैं उसमें हेल्पलेस हूँ, मैं नहीं कुछ कर सकता हूँ। आप कहिए जिस भी भाषा में मुझे पढ़ाने को कहा जाएगा मैं उस भाषा में पढ़ाऊंगा। आप समझें कि आई एम बाउंड बाय द रूल्स ऑफ द ऑर्गेनाइजेशन, आई कैन नॉट ब्रेक दोज रूल्स। मुझे जो भी कहा जाएगा उस तरह से मैं कंटिन्यू करूंगा। अभी मुझे इंग्लिश में पढ़ाने के लिए कहा गया है, सो डोंट वेस्ट योर ऑल एनर्जी इन दिस लैंग्वेज ट्रांसफॉर्मेशन। मैं जानता हूं कि ये तुम्हें मेंटली ज़्यादा परेशान कर रहा है, बाकी आप सभी बीटेक करके आए हुए हो तो इतनी अंग्रेजी जानते हो, और मेरी अंग्रेजी कोई शशि थरूर जैसी मैं नहीं बोल रहा हूँ कि तुम्हारे दाएँ बाएँ से निकल जा रही। आई एम स्पीकिंग द कोलोकियल लैंग्वेज, जो आप लोग बोलते हो वही बोल रहा हूँ, ठीक है। तो वो अंडरस्टैंडेबल है अगर समझना चाहोगे तो, बट इफ यू आर नॉट वांटिंग टू अंडरस्टैंड then the best way is contact the management. They will be listening you, they are to rectify your problems. I'm just a teacher, my duty is to teach you the topic, right? Now that duty I will perform with whole honesty, but in that duty I have been told to follow the particular medium, and that medium in this class has been told me to follow English one. So I will be continuing in English, right? So don't waste all your energy in all these things. Let us come and focus on studying, right? These are the topics of which we have to cover. Now let us try to see what are the resources, a source of study. Which kind of source of study we have to follow? First of all, we need to study class notes. It means we need to attend classes. But only class notes are not sufficient. Theory book is also required. When I taught you technical topics, there may be several students who has read technical topics in my classes, maybe EDC, digital or analog, any subject you may have read from me. So there I didn't tell you to read this book because the time provided in the technical subjects is huge. You are given 50 hours, 60 hours, 70 hours. So each and every theory is clearly dictated in the class. Each and everything is covered in the class in depth because of the huge time available. But here time provided is very limited. So we cannot cover each and everything. So those topics which are very much theoretical, they have already been covered in this book. So please, whenever you come for the class, whenever you join this class through this digital medium, please keep theory book along with you. So I would be telling you what are the topics of which you have to read from that book and what are the topics of which you have to follow in the notes. So theory book plus notes both are required in order to proceed in this subject. Second one is a workbook that may have been provided to you by the Medici management, and the third one is test series. These are the compulsory sources you need to follow. Apart from, if you can, then I have a Telegram group, and on that Telegram group I have given a practice question set, practice question set of 777 questions. This much of the questions has been provided. The Telegram group is named as, ये टेलीग्राम पर ढूंढिएगा, @अनुनाद ANUNAAD 22. Yeah, you can search like this also, ANUNAAD, Anunad. Let's be in resonance. Let's be in resonance. In this group, the notes are available in the PDF format. You can go for these practice questions set. Large number of questions are there. So this much of the resources are sufficient to proceed in the subject. So let's start with the discussion, and let's start with the introduction of the subject, and then we would be moving towards the chapters. Rohan, this is not for GATE syllabus, dear. This is not for GATE syllabus. This is only for engineering services paper 1. So any student who is appearing for GATE only, he is not going to appear for engineering services. He may leave this class, because this is only for engineering services, but very important for engineering services, because in engineering services it is having huge weightage, very scoring subject, but for GATE it is useless. It is not in the syllabus of GATE examination, right? Someone asked how much time I am going to take. Roughly around 35 hours would be taken in this subject. Roughly around 30 to 35 hours. So 30 plus would be the precise term. It depends upon my energy, your writing speed, and several other factors. So 30 to 35 hours that we plan. Not exactly, we never finish it in exact 30 hours, we never finish it in exact 35 hours. Somewhere in between 30 to 35 hours would be required. Let's begin. Material science. What is material science? This is the first thing you must know. And they have asked once this question also related with the definition of material science. In Engineering Services 2017, they asked one question. So listen me very carefully and try to understand each and every explanation. Let us suppose we are an engineer. Not suppose, actually we are engineers. So we need to design several engineering structures in every branch. Suppose you are a civil engineer, then you have to design some bridge, some column, some pillar, some beam, anything. So you have to design some engineering structures. You are a mechanical engineer, you have to design some automobiles, you have to design a car, you have to design a truck. You are an electrical engineer, you have to design some machines, like you have to design motor, you have to design transformer, etc. You are an electronics engineer, you have to design IC chips, integrated circuit chips, you have to design transistors, capacitors, and all those things. So what I am wanting to tell you, we have to design several engineering structures. In order to design any engineering structure, we need certain material. So we have to work with materials to fulfill our engineering requirements. हमें अपनी इंजीनियरिंग की जरूरतों को पूरा करने के लिए कुछ मटेरियल्स के साथ काम करना पड़ेगा. We need to work with materials to fulfill our engineering requirements. But to make a particular thing, there are n numbers of materials, and we have to select the best material for a particular applications. किसी पर्टिकुलर काम को करने के लिए, किसी पर्टिकुलर चीज को बनाने के लिए बहुत सारे मटेरियल हो सकते हैं, और उनमें से हमें बेस्ट चुनना है. We have to select the best material out of the available slot. How can we select the best material? We can select the best material only if we know the property of the material. Until we do not know the property of material, it would be very difficult for us to select the best material. For example, you have to design a wall. आप एक सिविल इंजीनियर हैं और आपको एक वॉल बनाना है. Let us suppose you have to make a house. So to make a house, to make a wall, you have several choices. You can use clay. And in ancient time, people were using clay. और मिट्टी के घर बने होते थे. People were using making mud houses. But there is a problem with the mud. There is a problem with the clay. It does not have long durability. When heavy rain comes, or when natural calamities can, it may collapse. Your engineering structure may fail. So in order to give it durability, we searched other materials. So we can go for the metals. Let us suppose we make a wall of steel. Yes, we can make it, but there are two problems. One, first problem is it is costly as comparison to the mud, and the second problem is steel get corroded in the environment. So there is a problem of oxidation, there is a problem of corrosion, which will again reduce its life. So in order to avoid the corrosion, you said that let's go for the gold. Let's make a wall of gold. But that is beyond our capacity because gold is very costly material. So we cannot afford that much cost. So we have to check on the several parameters. There should be the durability of the material so that it can sustain for the longer duration of time. There should be economic related with the material. It should be economic. It should be cost effective. It should be hugely abundant so that easily we can get this material to make the structure. So all these are the parameters which we have to keep in mind. And by keeping all these parameters, we got concrete, and we said that brick and concrete are economic as well as durable. So let's make this wall with the brick and concrete. So this conclusion that brick and concrete are better to make this structure, this conclusion we have not withdrawn in 1 day or 2 days. Over the period of time, working with the several materials on the basis of experience, on analyzing the properties of several materials, we got this conclusion that this particular set of material is good for this particular applications. That is the idea behind the study of material science. We need to work with the materials, we need to understand the properties of the materials in order to select the best material for a particular application. किसी पर्टिकुलर एप्लीकेशन के लिए बेस्ट मटेरियल्स चुनने के लिए हमें मटेरियल की प्रॉपर्टीज को जानना बहुत जरूरी है. And in this subject we will try to investigate that. But we all know that the relationship between the property of the material and structure is closely. For example, suppose I tell you कि how much friction would be available on this surface. So this friction is a property of the material, and I want to know how much friction would be there. So I can say that if the surface is smooth, then friction is less, but if the surface is rough, then friction will be more. So this property, having frictional force, depends upon the surface structure of the material. This I gave you one example. Not only the surface structure, atomic structure, nuclear structure, electronic structure, molecular structure, grain structure, crystal structure, microstructure, all these structures are going to affect the property of the material. It means the material properties are closely related with the internal arrangement of atoms in the material. Material properties are closely related with the arrangement of internal components in the material. So in this subject, we are trying to investigate the relationship between the structure and property of the material, so that we can select the best material by knowing its property for a particular application. So that we can select the best material for a particular application. पानी पी लूं तो फिर आगे बढ़ता हूं. Now one very important thing which we have to keep in mind. In this subject we are not going to study the behavior or properties of any engineering component. For example, if you say that there is a column, you apply certain force on the column, how does that column behave? This we are not going to study in this subject. So the behavior of engineering components, that is not the matter of discussion in this subject. For example, you take a transformer and you say that we are giving certain magnetic field, how does the transformer behaves? We are giving certain electric field, how does the transformer behaves? That is not the part of this subject. But what we have to study in this subject? We have to study with which material this transformer is made. So take that material out, apply certain force on the material and see the behavior of that material. That is the matter of discussion in this subject. This difference must be clearly understood by each and every student in the class, that we are not focused with the study of the behavior of engineering components. हम किसी engineering component का behavior यहाँ पर नहीं पढ़ना चाहते. We are not wanting to study transformers, we are not wanting to study bridges, we are not wanting to study vehicles, we are not wanting to study IC chips. We are wanting to study the materials with which these components are made. So behavior of the material is the matter of concern in this subject, right? One more thing. Just by merely, shall I take the tea? I am just taking your permission, although even if you do not give, still I will take, just saying it. Just by courtesy. How's the tea? You can check it, please. Let's see. Wow, it's too good. So let's begin to understand. Some of you may be very furious how the blunt this man is, and you may be frustrated. कुछ लोग तो एकदम पूरा गुस्से से भरे होंगे कि गलत आदमी भेज दिया हमारी क्लास में, मेरी जी पैसा ले लिया, ये कर लिया. अबे कूल डाउन, जाओ एक गिलास पानी पी करके आओ, ठीक है? एंड बी रिलैक्स्ड. Be seated in my class. You are going to develop a very healthy relation with a person who will be very important in your journey. आपकी इस जर्नी में, आपकी सफलता की इस जर्नी में आप एक ऐसे व्यक्ति से आज मिल रहे हैं जो आपकी इस जर्नी का एक बड़ा इंटीग्रल पार्ट बनेगा. सो ये गुस्सा उस्सा हटा करके बड़े प्यार से आइए, मेरी क्लास में बैठिए आराम से. एंड डोंट वरी अबाउट द लैंग्वेज. यू विल बी एबल टू अंडरस्टैंड ईच एंड एवरीथिंग इन द क्लास, राइट? सो कम टू माई क्लास. वो क्या है ना, मैं पूरे भारत को एक समझता हूँ. सो फॉर मी देर इज नॉट द स्टूडेंट्स ऑफ ओनली हिंदी बेल्ट. फॉर मी देर आर स्टूडेंट्स फ्रॉम द सदर्न पार्ट ऑफ द कंट्री, देर आर द स्टूडेंट्स फ्रॉम द नॉर्थ ईस्टर्न पार्ट ऑफ द कंट्री, देर आर द स्टूडेंट्स फ्रॉम बंगाल, देर आर द स्टूडेंट्स फ्रॉम सेवरल अदर स्टेट्स, उड़ीसा एंड ऑल दैट. सो ऑल ऑफ देम आर नॉट comfortable in Hindi. In Hindi, the students who are comfortable, they are from merely 7-8 states. Right? So from remaining states, there are several other students, so I have to address them also. So आइए जरा एक गिलास पानी पी करके आओ और उसके बाद बैठो क्लास में, समझ में आएगा. Come back. Let's go. So I was saying that we are not wanting to study the behavior of component. Instead, we are wanting to study in this subject the behavior of the material with which these components are made of. Suppose transformer has several materials. You use iron cores, you use copper wires. So we are not wanting to study how does the iron core is behaving. We are wanting to study how iron is behaving and how iron is suitable to make the iron core in the transformer. So how does transformer behaves? That's not the matter of discussion, but how does iron behaves? That is the matter of discussion in this subject. Right. So let us proceed. Just merely observing the मटीरियल, वी कैन नॉट कंक्लूड अबाउट द मटीरियल प्रॉपर्टीज. किसी मटीरियल को देख करके उसकी प्रॉपर्टी के बारे में कमेंट कर पाना संभव नहीं है. ये एक मटीरियल है, दिस इज अ मटीरियल, एंड जस्ट बाय ऑब्जर्विंग दिस मटीरियल हाउ कैन आई से दैट कि व्हाट आर द प्रॉपर्टीज ऑफ मटीरियल? नो. In order to know the properties of this material, we have to perform several experiments. Without performing experiments, I cannot say what is the property of this material. So we need to perform several experiments in order to know the property of the material. Material की property को जानने के लिए हमें तमाम सारे experiment perform करने पड़ेंगे. कैसे? Let us. जैसे मुझे आपकी प्रॉपर्टी पता करना हो. अच्छा, चाय आप लोगों को अच्छी नहीं लगी क्या? गुस्सा हो? आइए, कोई बात नहीं. सपोज मुझे आपकी प्रॉपर्टी पता करना हो. Let us suppose I am wanting to know what is your character, what is your property, what is your behavior. So just by observing you, I cannot comment about your behavior. So to know your behavior, I have to do certain experiments. So मैंने क्या कहा? आपके पड़ोस में खड़े हुए एक लड़के से कहा कि he should slap you. And he has slapped you. Once you are slapped, then I will be observing your response to this excitation. You have been excited by some other person. He slapped you. and I am wanting to observe your behavior, your property for this external excitation. How does you are responding to this excitation? Suppose you collapsed, you got slapped and you collapsed. Immediately I will be writing in my diary, the person is very weak. So your property is you are a very weak person. Suppose you didn't collapse, you bear it, then I will say that you are a strong person. So your property is you are strong, I will be writing it. So whether you are weak or you are strong, how could I know this? I came to know this by applying certain external excitation and by observing your response for that excitation. Same happens with the materials. In order to know the property of a particular material, we apply certain excitation and we observe the response of the material for that excitation. That response of the material for the applied excitation gives us the property of the material. मटीरियल का रिस्पॉन्स किसी एक्सटर्नल इनपुट के लिए उसकी प्रॉपर्टी बताता है. किसी एक्सटर्नल एक्साइटेशन के लिए जो मटीरियल का रिस्पॉन्स है, दैट रिस्पॉन्स इज टेलिंग अस अबाउट द प्रॉपर्टी ऑफ द मटीरियल. नाउ there will be the several kind of properties depending upon the type of the input given, type of the excitation given. Excitation means input. That slap is a excitation. So what kind of input we are giving, that will decide what kind of response we would be getting. Suppose we are applying a mechanical force, then the response of the material would be known as mechanical property. Suppose we apply temperature, we increase the temperature, so we are giving thermal energy as excitation. So the response of the material is known as thermal property. Suppose we put light on the material, so the response of the material, whether the light is reflected, refracted or transmitted, that is the optical property of the material. Suppose we put the material into a magnetic field, so how does the material respond for that magnetic field, whether it is attracted, repelled away, what happens? That's known as the magnetic property of the material. Suppose we apply a voltage. Voltage is what? EMF, electromagnetic, electromotive force. ऐसा force जो electron को motivate कर सके कि भाई तू दौड़ जा. EMF is a force which can motivate electron to run. So if the electron is running, the material is conductor. If it's not running, the material is insulator. If it's in dilemma whether I should run or not, then the material is semiconductor. So the electrical behavior of the material is known under the influence of some external EMF, some voltage. So that's known as the electric property of the material. So what I'm wanting to conclude that the properties of the material will depend upon the type of the excitation given. किसी मटेरियल की प्रॉपर्टी इस बात पर निर्भर करेगी कि उसको किस तरह का इनपुट दिया गया है. अगर मटेरियल को हमने इलेक्ट्रिकल इनपुट दिया तो रिस्पांस इलेक्ट्रिकल प्रॉपर्टी कहलाएगा. मैकेनिकल इनपुट दिया तो रिस्पांस मैकेनिकल प्रॉपर्टी कहलाएगा. So based on our excitation, I would be getting the response of the material, and that response will be known as the property of the material. Now, these properties are very much related with the internal structure of the material. So in order to know the response of material, we must investigate the relationship of this response with the internal arrangement or internal structure of the material, and that is the matter of discussion in the subject. So let's write first the definition of the subject, and then I would be going for further discussion. So till now I told you कि material science involves investigating the relationship that exists between the structure and properties of materials. Structure and properties of materials. Structure and properties of materials. Material science involves investigating the relationship that exists between the structure and properties of materials. The structure of material, material usually relates to the arrangement of its internal components. Relates to the arrangement of its internal components, such as atoms, molecules, etc. Atoms, molecules, etc. How these components are arranged, that will result into the structure of the material. So, structure of material usually relates to the arrangement of its internal component. What is property? Basically, property is nothing but the response of material for certain applied external force. So, a property is material's response. So, property is response of material for certain applied external excitation. Property is response of material for certain applied external excitation. एक्साइटेशन का मतलब इनपुट मान सकते हैं आप. एक्साइटेशन. How does the material is responding for a particular input, that is known as property of the material. Properties of solid materials can be classified as properties of solid materials. Solid materials can be broadly classified as, first, mechanical properties. Mechanical properties of material. Properties of materials. Second one, electric properties of materials. Electric properties of materials. Third, magnetic properties of materials. Magnetic properties of materials. Fourth, thermal properties of materials. Fifth, optical properties of materials. Optical properties of materials. 6, deteriorative properties. These are the properties which affect the behavior of material over the period of time. Deteriorative properties of materials. like corrosion, creep, etc. They affect the behavior of material over the period of time, deteriorative properties of materials. So the properties which has time dependent behavior, they would be known as deteriorative. So broadly we have to study these kind of properties for the various materials in this subject. So this is the definition of property and definition of structure. So basically we are not going to bother about the response of a particular component in this subject. Instead, the response of a particular material for any applied force. So we can say that material science does not involve. I would like to make this definition a little bit more clear. Material science does not deal with the study of behavior of material science does not deal with the study of behavior of engineering components such as buildings, machines, automobiles, IC चिप्स. हर ब्रांच का एक एग्जांपल ले लिया हमने. Material science does not deal with the study of behavior of engineering components. Instead, it deals with the study of materials या behavior of materials with which these components are made. These components are made of. Instead, it deals with the behavior of materials with which these components are made of. So material science does not deal with the study of behavior of engineering components such as buildings, machines, automobiles, etc. Instead, it deals with the study of materials with which these components are made. This definition must be clearly understood. Sometimes we make mistake. We apply a force on a particular engineering component and we say that the study of the behavior of this component is material science. No. We are not bothering about the behavior of a particular component. Instead, we bother about the material with which the component is made up. That must be clearly understood. Please note down this definition of material science. Please clearly note it down. Once you have noted it down, please inform me. Good. So note कर चुके हैं. Good, noted, comfortably, right. So shall we go ahead? अच्छा, कुछ प्रॉब्लम हो गई मेरी स्क्रीन पर, शायद आपके कमेंट नहीं पहुंच पाए, तो मैंने बीच के कुछ कमेंट नहीं देखे. लेट मी सी व्हाट हैपन विद द कमेंट्स. अरे बहुत सारे कमेंट. Achilles is writing, sir, but see, when we know we would be knowing the structural behavior, then only we can select the material. Yes, I can understand. We should know the structural behavior. That is part of different subject. You study for that structural engineering, or you study for design engineering. Those are the different things. They are not the part of material science, right? You know the structural behavior, and then according to your requirement, let's select the material. So both are two different things, right? Here we have to study the material only. We need not to study the structure, right? So you are correct. I say that we must know the behavior of the structure. So that is the separate thing. You know this is the behavior of the structure. Now to match that behavior, you have to select the material. So let's study the various materials and select which material is fulfilling your requirement. Then that material would be used for that particular structural purpose, right? चलिए, धन्यवाद आप सबके इतने प्यार के लिए. तमाम सारे आपके मैसेजेस थे, हमने पढ़ा. किसी ने लिखा कि अरे हम समझ रहे हैं सर आग बबूला हो गए होंगे. नहीं, मैं आग बबूला होता ही नहीं हूँ. मेरा जो गुस्सा होने का मैक्सिमम पीक ड्यूरेशन है वो कुछ सेकंड में होता है. सो आई कैन नॉट बी एंग्री फॉर द लार्जर ड्यूरेशन ऑफ टाइम. डोंट वरी अबाउट दैट. बी रिलैक्स, बी कूल. I take the responsibility of the subject. You will understand this. This is my guarantee. आपको समझ में आएगी, पूरी तरह से समझ में आएगी. Till now, we studied the property and the definition of structure, but we have not seen the definition of material. What is material? Someone may ask. Basically, it is matter. Matter is what? Which consists of some space, which consists of mass and which occupies some space. That is known as matter, a material. So material is something with the help of which we can design few structures. That will be known as material. So the question is कि there are infinite materials in the nature. भाई हम अभी सुबह सुबह नाश्ता किए हैं, वो भी एक मटीरियल है. We have taken breakfast, that is a material. Shall we have to study that material? No. We cannot study all the materials. आप रास्ते से बाइक दौड़ाते हुए जा रहे थे, टसन में टूट गए, मतलब आप गिर गए, बाइक टूट गई, आपका हाथ टूट गया, डॉक्टर के पास गए, उसने एक रॉड डाली. दैट इज ऑल्सो मटीरियल. बट दैट्स नॉट द मटीरियल व्हिच वी हैव टू स्टडी. We have to study those materials which are used to design engineering structures. Such materials which we use in various engineering disciplines to design engineering structures, they are known as engineering materials. So we have to focus in this subject mainly up to the study of engineering materials. We are not going to study each and every material. I'm happy to tell you that most of the engineering materials are common. Our way of using them in various branches is different, but they are the common materials and most of them are solid. So we have to focus ourselves mainly up to the study of solid engineering materials. Although in few cases we use liquids, we use gases also, but that we can study separately in our engineering branch itself. But as a common syllabus, we need to study those materials which are mainly the common materials in various engineering disciplines to design a particular structure. For example, हम सभी sand जानते हैं, ठीक? Sand means SiO2. We all know this, SiO2. This is sand, popularly, chemically known as silica. This is a common material, right? This is the common material. Let us suppose a few questions are there, I would be taking after this explanation. Suppose I give this material to civil engineer. मैंने ये material किसी civil वाले को दे दिया. Now he would be observing the property of this material from civil engineering point of view. He will say that it is a fine grain. Let's mix it with the cement and let's make concrete. So it will reduce cost of the structural material as well as a reinforcing medium. It will increase the strength also. So he would be using it as a fine grain to make concrete. कंक्रीट बनाने के लिए इसे फाइन ग्रेन की तरह यूज करेगा. ठीक. Let us suppose I give the same material to a mechanical engineer. What will he do? He will take it up to the molten state and then slowly he will cool it, and after slowly cooling, this material will convert into a beautiful material that is known as quartz. And quartz can produce mechanical vibrations. So whenever he is requiring mechanical vibration, he can use this material. So this way he is using the same material for this purpose. Let us suppose I give this to electrical engineer. So he is concerned with the electrical property of the material. So what will he do? This man will make electrical insulator with this material. And whenever he is wanting electrical insulator, he will use this material as an insulator. Where it is required, let us suppose he required to isolate two conductors, so he will place this between the two conductors. So it will be working like an electrical insulator. Suppose I give this to an electronics engineer. So what will he do? He will extract silicon and make an IC chip and will sell it as a computer, laptop, whatever. My point is the material is same, and same material can be used by the various engineers to design certain structures. So if we know the basic property of this material, let's try to study the basic property of this material. So whenever I would be requiring any particular application, so we will judge the material according to that application. And this is the reason why basics of material science is being taught to every engineering discipline. Okay, let's try to understand what is silica. Once we know the silica and rough idea about the structure of the silica, rough idea about the behavior of the silica, then whatever is the requirement, according to that we can select this material. And we can modify its character according to our need also. So that is the reason behind the study, right? Someone asked, suppose we are civil engineer and we don't know the electric properties. That's why I am here to teach you electric properties. So once you read the electric properties, then you can judge the material from the electric properties point of view also. So don't worry about that. We are going to study the basic properties of all the materials, and then we can select the material for that purpose. But suppose you are wanting to design structure, so for the structure you need to know the strength of the material, you need to know its ability to withstand various loads. You don't want to study the electrical character of the material, then why should you be taught the electrical property? You need not to be taught the electrical property, right? So come back to the point. Let's define the material. So I am saying that what is material? Material, let's define it. Material can be defined as something. Material can be defined as something that consists of matter, that consists of matter, has some mass and occupies some space, and occupies some space, right? It is the stuff with the help of which something can be designed. It is the stuff with the help of which something can be designed, with the help of which something can be designed. Since we have to study engineering materials, so we can say that engineering materials can be broadly classified as engineering materials can be broadly classified as, first, metals and alloys. Metals and alloys. Every one of us has used material in our life. घर में चाकू है ना, knife, that is what? That is made up of some metal. So we know the basic character of metal. These are heavy, these are having high strength, they may have high melting point. Some things without even study, you know just by observation. So metals and alloys. Second one is ceramics and glasses. The examples of ceramics and glasses are like bricks, concrete, tiles, stones. All these are the categories of ceramics and glasses. They are again heavy materials and are having high strength. Then the next one is organic polymers. Organic polymers. Organic polymers means plastics like polyethylene, polyvinyl chloride, PVC, nylon, etc. So frequently we use these materials. These are light in weight, although they are not having that much strength as the earlier two one is having. So these are the three basic class of the materials. But modern engineering requirements has gone far away. मॉडर्न इंजीनियरिंग की जो जरूरतें हैं वो सिर्फ इन तीन क्लास ऑफ मटेरियल से फुलफिल नहीं हो पा रही. द रिक्वायरमेंट ऑफ मॉडर्न इंजीनियरिंग has not been fulfilled with only these three classes of the materials. Suppose we require a material where we need high strength but it should be lightweight. So both of these properties are contradicting. Generally high strength is offered by the metals or ceramics, but they are heavy in weight. Light weight is offered by the polymers, but they do not have that much strength. So now if I use any one of these for this particular application, we cannot get the satisfactory performance because we need a material which should be light in weight but high strength. आप कहेंगे ऐसा क्यों जरूरी है? जरूरी है. Let us suppose we have to design a component of a plane. हमें plane का कोई component बनाना है. So if we have to design a component of plane, that plane should be at 30,000 height. That should be flying at 30,000 height, 30,000 feet height. So at such a height, I don't want to take a material of very heavy weight. As a design engineer, I would be wanting to take a material of lightweight. But you know, when the plane would be running with such a high speed, then the component may experience a large stress, they may experience a large pressure. So they should have capability to withstand that pressure also. So I need a material which should be light in weight, but it should have capability to withstand a high pressure, means it should have high strength. So such applications desire materials which are light in weight but high in strength. But none of these are capable to produce these two properties simultaneously. So when we want contradicting nature of properties, then we have to use two or more than two materials in order to get the desired properties. So when two or more than two materials are used to fulfill our engineering requirements, so we make a new class of material, and that is known as composites. So basically we can say that the composites are nothing but the mixture of any of these two. You can take any of these two or you can take all three to make a new material, and that material will be known as composites. But most of the modern engineering requirements are fulfilled by the composites. So composites become a very important class of material, and we have to study them thoroughly as well, because they are nowadays very frequently used. Although we are making them to fulfill our engineering requirements, so they are not the homogeneous class of materials as metals and ceramics or polymers available naturally. Instead, we are making them by mixing two or more than two materials to make a new materials to fulfill our engineering requirements. So these are the basic classification of engineering materials, and we have to focus in this subject for this classification. This was all about the introduction of this subject, that is the introduction of material science. And in the past years, you have got few questions related with the introduction. So please note down this, then we can proceed for the chapter 1. Please note it down. Yes, तुषार चंद्रा जी, बट कार्बन फाइबर अकेले नहीं यूज होता है. कार्बन फाइबर along with the plastic, so that becomes composite. I will be teaching you. Composites नाम का एक पूरा चैप्टर ही पढ़ाएंगे आपको. अर्पित देव पांडे जी कह रहे हैं इंग्लिश लैंग्वेज से प्रॉब्लम नहीं है, बस सुनने में कंसंट्रेशन के साथ सुनना पड़ता है. समझ, ये तो और भी अच्छी बात है. यू विल पुट ऑल योर कंसंट्रेशन टू लिसन मी, तो और मज़ा आएगा. अदरवाइज आप बीच बीच में सोचते रहेंगे कि फलाने के खेत में चना बहुत अच्छा है, शाम को होरा भूजने जाना है, कैसे चोरी करने का जुगाड़ किया जाए, तो फिर उससे मज़ा नहीं आएगा बेटा. ठीक है, क्योंकि ध्यान आपका क्लास में नहीं बल्कि चना को चुराने में लगा रहेगा. राइट. ठीक, अगर गांव से बिलोंग करते होंगे तो समझ रहे होंगे क्या कहा मैंने, शहरों से बिलोंग करते होंगे तो नहीं समझ पाएंगे. कोई बात नहीं. नोटेड. गुड. बहुत अच्छे, तुम लोग तो बड़े तेज स्टूडेंट हो, बड़ी जल्दी नोट कर लेते हो भाई. हैप्पी. चलिए चैप्टर 1 की तरफ चलते हैं. लेट्स गो फॉर चैप्टर 1. Yes, Mukul Sachdev is asking that composites are artificial material. Yes, most of the composites are artificial. Although when I will be teaching you composite, then I will be telling you there are certain natural composites also. For example, this skin, that skin is not made of one material, that is made of several material. It is also a composite. And it is a natural composite. So there are certain natural composites also, but most of the composites which we are used to design the engineering structures, they are the artificial materials. So you can frequently say that कि these are the artificial materials. So बड़े आराम से आप कह सकते हैं, इसमें कोई दो राय नहीं है. ठीक. Let's go for the next topic. बहुत अच्छा आपने लिख लिया. So let's move on to the first chapter. First chapter की तरफ चलते हैं. बहुत बढ़िया, बहुत बढ़िया. ऐसे ही आप मुझसे इंटरेक्ट करते रहिए, क्या भाषाई चक्कर में पड़े हुए हैं. बहुत अच्छे. यू कीप ऑन इंटरेक्टिंग विद मी, वी विल स्टडी द सब्जेक्ट इन द मोस्ट ब्यूटीफुल वे. ईसी वालों, इलेक्ट्रिकल वालों, तुम्हें तो अभी मुझे और झेलना पड़ेगा 20 घंटे. आफ्टर दिस सब्जेक्ट यू हैव टू स्टडी द मटीरियल साइंस, टेक्निकल आल्सो. कब शेड्यूल लगेगा आई डोंट नो, बट यू हैव टू स्टडी वन मोर सब्जेक्ट विद मी. This is, we are studying basics of material science. Then you have to study the electrical engineering materials, and that I would be teaching you separately. उसके लिए जब भी schedule लगेगा. Few topics overlap here. So those topics which I cover here, that will not be covered in the technical syllabus. And time is also allocated according to that. Whatever I cover here, that will not be again taught to you. So paper 2 material science and paper 1 material science will go hand in hand. Although the things which we teach here, they would be utilized in the paper 2, but that is not sufficient for the paper 2. Right, let's go for it. ओह अनुभव जी, ध्यान रखा जाएगा आपकी बात का कि थोड़ा और समय आपको दिया जाएगा. थोड़ा साथ साथ लिखने की कोशिश करते रहिए. आगे से ध्यान दूंगा मैं कि थोड़ा समय और मिले. चैप्टर 1, लेट्स बिगिन विद द atomic structure and chemical bonding and chemical bonding. So कथा आरंभ करते हैं यहां से. Let's begin with the story. अच्छा, रिकॉर्डेड मिल गया है. पंकज नागले जी कह रहे हैं रिकॉर्डेड मिल गया है. तो रिकॉर्डेड मिल गया है तो फिर तो कोई बात ही नहीं. वन मोमेंट, कुछ टेक्निकल ग्लिचेस आ गया. मेरी स्क्रीन चली गई है. देखता हूं किसी को बुला के. So let's begin with the atomic structure and chemical bonding. There was some technical glitch because of which I discontinued. Let's come back. So why I'm wanting to teach you atomic structure? I told you that the properties of the material are influenced by the internal arrangement of components. And what is the internal component of material? The basic internal component of the material is atom. So until and unless we do not know the structure of the atom, we cannot comment about the property of the material. So first of all, let us investigate the fundamental particle with which the material is made up of. Let's begin with the basic unit with which the material is made up of, then only we can comment about the behavior of the material. That's why we have to study the atomic structure. Before entering into this topic, let me make one thing very clear, and that is we are not going to study atomic structure in depth in this subject because we are not studying physics or chemistry here. I would be touching any topic only as per the requirement to explain the material properties. So I would be teaching atomic structure only from that perspective, whatever is the requirement to understand the property of the material. So don't think in that way that I would be teaching each and everything related with the atomic structure. That's not practically possible in this subject. We would be trying to finish it in today, and tomorrow in 2 lectures I would be trying to finish this chapter. So in 2 lectures, in roughly 5-6 hours, we are trying to complete the atomic structure. It means we are not going into the depth of the atomic structure, and that's not the need also. As far as number of questions are concerned from this topic, in last 6 years there are 6 questions from this chapter. It means on an average there is 1 question from this chapter each and every year. But it's not like that. In some of the years they have asked 2 questions, in some of the years they have not asked any question. But if we talk about the average, then there are 6 questions in last 6 years. It means on an average 1 question from this chapter. Questions are very simple and straightforward, right? Let's go. Let's go. During the last decade of 19th century, a man came named as Sir John Dalton. Sir John Dalton was a British school teacher, and he has written a book named as New System of Chemical Philosophy. And in that book, first time he discussed about the atoms. So from there we start with the discussion of atoms. After that, several other big personalities came and they talked about the atoms. But John Dalton was the first man, as per the accepted science nowadays. Although there is a debate, some of the Indian scholars says that Kanadi Muni was the first man who talked about the atoms. But the thing which are internationally accepted, that is that John Dalton was the first man who talked about the atoms. So let's begin from there. Mr. Dalton says that matter is made of some tiny indivisible structure. Everything, matter means कोई भी material, हर एक चीज जो दुनिया में है, that is a matter. I, me, you, everyone, this camera, this watch, this dress, everything is made up of some matter. So the man said that matter is made up some tiny means very small. The matter is made up some tiny means very small. हिंदी वालों सूक्ष्म, ठीक, and indivisible. Indivisible means which cannot be further divided. हिंदी वालों अविभाज्य. So the matter is made up some tiny and indivisible structures. He named these structures as atoms. उसने इन structures को नाम दिया एटम. डाल्टन भाई साहब कह रहे हैं कि हर एक चीज कुछ सूक्ष्म अविभाज्य कणों से मिलकर के बनी है, और उन सूक्ष्म अविभाज्य कणों को हम एटम कहते हैं, हिंदी में जिसे परमाणु कहते हैं. Matter is made of some tiny indivisible structures, and those tiny indivisible structures are known as atoms. Why he gave the name atom? The reason is very clear. In ancient time in Greek, tomio word means cuttable, which can be divided further, which can be cut, and a is used for not. So atomio means which is not cuttable. So atom is atomio, which is not cuttable, which is not further divisible. That is why the name is given as atom. The next one was the big statement given by this personality. He says that atoms can neither be created nor destroyed. एटम को ना ही क्रिएट किया जा सकता है और ना ही खत्म किया जा सकता है. This was a big statement. Even in engineering services 2017 they asked this statement. एक वो क्वेश्चन आते हैं ना, statement 1 and statement 2 both are true, 1 is true, 2 is true, like that ABCD option they make. So in that statement type of question, one statement they have given that. And that statement was atoms can neither be created nor destroyed. This statement was given by John Dalton in his book A System of New Chemical Philosophy. That's 100% true. We cannot make any new atom. भाई हम ऐसी कोई नई चीज नहीं बना देते. Whatever things are available in this universe, we are making some things out of that only. So we are just transforming the shape. We are not making any new material. So creation of new material is not possible. जिस दिन हमने creation कर दिया, we will become God. If we are able to create new material, it means we are becoming God. We will be making our own parallel universe. That has not happened till now. Till now, whatever mass, whatever atom is available in the universe, we are actually making things only out of those mass, only out of those atoms. So we cannot create atoms. Also we cannot destroy atoms. यहां किसी को कंफ्यूजन हो सकता है, यहां किसी को कंफ्यूजन हो सकता है। क्यों? क्योंकि आइंस्टीन बाबा ने तो कहा है कि E is equal to mc square. Mr. Einstein has said that कि if mass m is given velocity c, it will get destroyed and it will become energy. So you may get confused कि Dalton may be wrong. No, Dalton is correct. In theory of relativity, Einstein has already said that कि any mass cannot be provided the velocity of light. अरे वो भाई अपना ये जो अभी स्टीफन हॉकिंस है, इसकी बहुत सारी थ्योरी है कि अगर हम वेलोसिटी ऑफ लाइट से ट्रेवल करने को पा जाएं तो ब्लैक होल में घुस जाएंगे, ये वो देश भर की नौटंकी टाइम ट्रेवल कर लेंगे, ऑल दोस। देयर आर सर्टेन हॉलीवुड मूवीज आल्सो मेड ऑन दिस प्रिंसिपल। So it's not possible to give any mass to velocity of light. And if it's not possible to give any mass velocity of light, it cannot be fully converted into energy and hence it cannot be destroyed. So we need to accept that कि atoms can neither be created nor destroyed. Atom को ना ही create कर सकते हैं और ना ही खत्म कर सकते हैं। ठीक है जी, let's agree. आगे ये एक बात कहते हैं कि atoms of a particular element are identical in all respect, including their physical, chemical properties, etc. But atoms of different elements will differ in their properties. ये भाई साहब कहना चाह रहे हैं कि किसी एक पर्टिकुलर मटेरियल के सभी एटम की सारी प्रॉपर्टीज एक जैसी होंगी। जैसे उदाहरण के तौर पर, फॉर एग्जांपल लेट अस टॉक अबाउट हाइड्रोजन या लेट अस टॉक अबाउट आयरन। सो ऑल द एटम्स ऑफ आयरन विल हैव all the properties same. Their atomic mass should be same, their atomic number should be same, their chemical properties should be the same, their electrical properties should be same. So every atom should have same character. But if I compare with the atoms of iron with the atoms of calcium, then their properties must differ. So according to John Dalton, atoms of a particular element are identical in all respect, but atoms of different elements will differ in their properties. And यही गलती हो गई। Here is a point which he could not explain. Why? Let us have a look. We know isotopes. Isotopes क्या है? For example, हाइड्रोजन के 1H1, 1H2, 1H3, 1H1, 1H2, 1H3. चेतन का क्वेश्चन है कि जॉन डाल्टन वाज अ ब्रिटिश स्कॉलर, व्हाई ही यूज्ड ग्रीक लैंग्वेज। गुड, इसके लिए आपको इतिहास पढ़ना पड़ेगा चेतन जी। एक्चुअली जितनी भी अंग्रेजी वगैरह निकल करके आई है, इनकी मदर लैंग्वेज है लैटिन, और लैटिन ग्रीक लोग यूज करते थे, वहीं से ये सब भाषाएं निकल करके आई हैं जो मॉडर्न इंग्लिश वगैरह हैं। जैसे जितनी भी इंडियन लैंग्वेजेस हैं, उनकी जो मदर लैंग्वेज है वो संस्कृत है, सो वहाँ से निकल करके आई हुई है। सो इसीलिए मैंने ग्रीक बोला हुआ है, जो मैंने बोला हुआ है पूरा सोच समझ करके बोला हुआ है। ठीक है, आइए 1H1, 1H2, 1H3, ऑल दीज थ्री आर द एटम्स। और ये क्या लॉजिक दिया आपने? फर्जी लॉजिक है। अरे मैं हिंदुस्तानी व्यक्ति अंग्रेजी में बात कर रहा हूं, तो वो अंग्रेज ग्रीक में क्यों नहीं कर लेगा? है, आइए 1H1, 1H2, 1H3, all these are the hydrogen atoms, but they have different atomic mass, and according to Dalton their atomic mass should be same. So John Dalton is not able to explain about the existence of isotopes. These are known as isotopes, which are having same atomic number but different atomic masses. They are known as isotopes, and John Dalton was not able to explain isotopes because he is saying that all the atoms of a particular element should be identical in their properties. So this man was not having this explanation. Similarly, we have isobars. Isobars are like this. Suppose you have calcium, and calcium is 2014, and you have argon 1840. नहीं, उल्टा लिख दिया क्या हमने? दो 8, हाँ ठीक है 1840, राइट। So now you see these two are the different elements, but their masses are same. So they will be known as isobar. And according to Dalton-Weisel, different atoms of different elements should have different properties, but here the properties are same. Here the masses are same. Mass is a property, that is a physical property, so that is the same. He could not explain about the existence of isotopes and isobars, but he laid a strong foundation that everything is made up of some tiny indivisible structures. Those structures are known as atoms, and atoms can neither be created nor destroyed. So we are not able to create any new atom. We are not able to destroy the atoms available in this universe. So it means we are not able to create something new. These two were the important points. Let's take these 2 points and let's move forward. Why he could not explain about the existence of isotopes and isobars, now we can explain it. Because he was not knowing about the subatomic particles. So later on research took place, and people came to know about the particles which exist in the atoms. They are subatomic particles. Basically they are electrons, protons and neutrons. So I would be talking about them, but before that let me tell you the 2 important points of the Dalton's atomic theory. I am not going to give name to any atomic theory. I would be naming few atomic theories, but not going to give name to this atomic theory. Rather I would be writing it in a point format, just as a note. So matter is made of, आप भी ऐसे ही लिखते चलिए, matter is made of very tiny particles, called as atoms, which are indivisible structures, Matter is made of very tiny particles called as atoms, which are indivisible structures. Next point is, atoms can neither be created, nor destroyed. ये कहने का मेरा मतलब है कि बी साइंटिस्ट एंड इंजीनियर्स कैन नॉट क्रिएट एटम्स, एटम्स कैन नीदर बी क्रिएटेड नॉट डिस्ट्रॉयड. बाकी कोई ना कोई तो क्रिएट कर ही रहा है, जैसे ईश्वर, भगवान, अल्लाह, वॉट एवर यू आर सेइंग, राइट. सो ही इज क्रिएटिंग इट. So some supernatural power is creating this whole universe. He is capable of creating a new man, he is capable of creating a new plant, he is capable of creating any new thing. We scientists and engineers are not able to create the new things. So atoms can neither be created nor destroyed. से मेरा मतलब है कि हम लोग कुछ नया नहीं क्रिएट कर सकते, बाकी यूनिवर्स में तो बहुत कुछ भगवान क्रिएट कर ही रहा है. ठीक है. अभिषेक सिंह नेगी जी लिख रहे हैं, सर बट द एंटायर यूनिवर्स इज एक्सपैंडिंग एट अ स्पीड फास्टर देन द स्पीड. अरे तो एंटायर यूनिवर्स एक्सपैंड कर रहा है तो ये हम थोड़े कर रहे हैं, कोई सुपर नेचुरल पावर कर रही है, उसको पढ़ो तुम. साइंस इज अबाउट द स्टडी ऑफ द नेचुरल फिनोमिनास, राइट. सो स्टडी इट एंड एक्सप्लेन इट. आई वुड बी टीचिंग दैट, राइट. My point is we as a scientist and engineer, we the human beings are not able to create new atoms. We are not able to destroy the atoms available. So जो universe का expansion हो रहा है, that we are not doing. It is a self grown process, right? It's not done by, ऐसा थोड़े कि कल आप सो करके जागे और आपने यूनिवर्स को थोड़ा खींच दिया. आज मैं उठा सुबह सुबह एनर्जी में और मैंने पकड़ा यूनिवर्स को खींच दिया. इट्स नॉट हैपनिंग लाइक दैट. इवन वी आर नॉट एबल टू नो हाउ दिस इज हैपनिंग प्रॉपर्ली. वी आर नॉट एबल टू नो. सो हियर आई मीन दैट वी एज एन इंजीनियर एंड साइंटिस्ट आर नॉट एबल टू. Saddam ji, I don't know about the teleportation of metal. God particle is not a new atom, Himesh. God particle is a new explanation for the existence of atom. जैसे डाल्टन ने एक्सप्लेन किया तो उनसे कुछ गलती हो गई समझने में. देन उसके बाद आगे लोग आए, बोहर, हीजनबर्ग एंड ऑल दोज, दे ट्राइड टू एक्सप्लेन, उनसे भी कुछ गलती हो गई है. तो उस गलती को अब हम लोग सही कर रहे हैं, ठीक है, गॉड पार्टिकल के नाम से. सो गॉड पार्टिकल इज एक्सप्लेनेशन फॉर द एटम, इट्स नॉट द न्यू एटम. ना भाई हिमेश जी, एटम कैन क्रिएट गॉड पार्टिकल, वह कुछ भी. पहले तो एक चीज समझ लो, इतनी सी साइंस है तुम्हारी और इन्फिनाइट सा यूनिवर्स है, ठीक है. तो हमारी साइंस के हिसाब से यूनिवर्स में कुछ नहीं होता है. साइंस इज फंक्शन ऑफ नेचर. सो भाई साहब, ये जो नेचर है ना, ये इंडिपेंडेंट वेरिएबल है. दिस इज इंडिपेंडेंट वेरिएबल, it is independent variable, and this your science is dependent variable. थोड़ा बहुत अगर आपको मैथ आती होगी तो अच्छे से इस बात को समझेंगे कि anything in nature will not happen according to the science, but everything in science will happen according to the nature, right? इंडिया के बड़े अच्छे टीचर हुए हैं S.C. वर्मा जी, बड़े अच्छे फिजिसिस्ट हैं, IIT कानपुर में पढ़ा करके रिटायर हुए. सो उनकी एक बुक चलती है कंसेप्ट ऑफ फिजिक्स. उसमें वो क्या लिखते हैं कि फिजिक्स नहीं, बेसिकली साइंस के लिए लिखते हैं, साइंस इज द स्टडी ऑफ नेचर. प्रकृति का अध्ययन ही विज्ञान है. प्रकृति का अध्ययन विज्ञान है. स्टडी ऑफ नेचर इज साइंस. इट्स नॉट दैट कि साइंस के हिसाब से नेचर होगा, राइट. तो हमारी तुम्हारी औकात नहीं है कि गॉड पार्टिकल पढ़ लिया तो अब एटम बना देंगे. वह अपनी औकात से बहुत बाहर है. ऐसे एक एग्जांपल से चलो समझा देते हैं तुमको, तुम्हारा सारा कंफ्यूजन दूर हो जाएगा. चेस जानते हो ना, जब हम बचपन में छोटे थे तो दुनिया में चेस के दो बड़े खिलाड़ी थे. मुझे उन्हीं के बारे में पता है, आज कौन है कम पता है उसके बारे में. एक थे मैग्नस कार्लसन रसिया के, और एक इंडिया के विश्वनाथन आनंद. ये दोनों 1 और 2 हुआ करते थे. Let us suppose Magnus Carlsen and Viswanathan Anand both are playing the game of chess. और एक व्यक्ति मेरे जैसा, he is observing this game. आपने देखा होगा when people play game, they do not speak even a single word. So they are not speaking. Player 1 is player 2. Player 1 is taking one step, then the other player is taking another step, then he is taking one step, then he is taking one step. Like that the game proceeds. I as an observer is watching this game. So in order to understand this game, यहाँ पर जो चीजें रखी हुई है ना, I will name them. ये हाथी है, घोड़ा है, गधा है, खच्चर है, whatever is that. I will name each and everything in order to understand the game. No matter whether our name is correct or not, I am naming it, right? In order to understand the game. Now once I have given the name, then I will start observing कि when player 1 ने कुछ चला तो उसके रिस्पॉन्स में player 2 ने ये स्टेप लिया, player 2 ने ये स्टेप लिया तो उसके रिस्पॉन्स में. Over the period of time, I will be formulating certain rules कि after soldier कितने स्टेप दूसरा सोल्जर चलेगा, रानी कैसे मरेगी, राजा कैसे मरेगा, whatever is that. ठीक. So we have formulated certain rules. We keep on writing those rules in a book. Now after few years I will start predicting कि इस चाल के बाद ये चाल होगा, क्योंकि over the period of time we have observed it very closely and we got to know that कि after this may happen. So we started to predict that कि after this will happen, after this will happen, after this will happen. अब हमको बड़ा घमंड हो गया. हमको ये लगा कि अरे यार हमको तो पूरा चेस समझ में आ गया, अब तो हम विश्वनाथन आनंद को हरा सकते हैं. एक दिन हमने विश्वनाथन आनंद जी से कहा, चाचा आओ खेलते हैं साथ में, लेट्स प्ले विद ईच अदर. I started to play with Viswanathan Anand. Since I have observed the game very closely, so few steps I would be taking correctly, उन्होंने कुछ चला, मैंने कोई चाल चली, उन्होंने कुछ चला, मैंने कोई चाल चली. After a moment of time, विश्वनाथन आनंद will start feeling insecure. उनको लगेगा अरे यार ये लड़का मुझे हरा देगा. The moment he will start feeling that कि this man will defeat me, he will take a new move जो पिछले 10 साल में उन्होंने नहीं चला होगा. Because he is the master of game, he can take any move. और मैं वहीं चारों खाने चित होकर के बेहोश हो जाऊंगा क्योंकि मैंने ये मूव तो देखा ही नहीं था, तो इसके लिए मेरे पास कोई एक्सप्लेनेशन ही नहीं है. दैट्स एग्जैक्टली अवर साइंस रन. नेचर, दैट इज द सुपर पावर. भगवान, सम सुपर पावर, गॉड एंड द नेचर, प्रकृति हमारे चारों तरफ, बोथ आर प्लेइंग अ गेम ऑफ चेस. आज तितली बना देते हैं, आज तुमको बना देते हैं, रात कर देते हैं, दिन कर देते हैं, पानी बहा देते हैं, झरना बना देते हैं, whatever. They are making lots of things. So they are playing the game of chess. Be the scientists and observers are the idiots who are writing the books. And after a few years, we start feeling that we have decoded each and everything related with this game. Now we started to play with the nature. The moment we started to play with the nature, that moment we did the wrong thing. Now, as soon as the nature will start feeling it's going to be defeated, it will take a new course of action which we have not seen from last so many years. और वहीं हमारी साइंस फेल हो जाएगी. इसीलिए कोरोना आता है. फेल हो गए तुम, अगले 20 साल पढ़ो तब तक सुनामी आ जाएगी. सुनामी अगले 20 साल पढ़ो कुछ नया आ जाएगा. सो नेचर इज ऑलवेज सुप्रीम. योर साइंस इज वेरी लिमिटेड. साइंस का कोई खास एग्जिस्टेंस नहीं है. साइंस केवल ऑब्जर्वेशन है. अब ऑब्जर्वेशन में बी रॉन्ग आल्सो. दैट्स व्हाई साइंस कीप ऑन इंप्रूविंग. भाई किसी एक व्यक्ति ने जो ऑब्जर्व कर रहा था उसको आंखें झपक गई, गलत ऑब्जर्व कर दिया, घोड़े की जगह गधा लिख दिया. अब कोई दूसरा आएगा वो बोलेगा अरे नहीं 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 नहीं, घोड़ा चलने पर तो हाथी चलना था, वॉट एवर इज दैट. सो वो करेक्ट करेगा. सो सिंस इट इज बेस्ड अपॉन ऑब्जर्वेशन, सो देयर इज ऑलवेज पॉसिबिलिटी ऑफ करेक्शन. और यही कारण है कि कोई एक एटॉमिक मॉडल अल्टीमेट नहीं हुआ. डाल्टन के बाद थॉमसन आए, थॉमसन के बाद रदरफोर्ड आए, रदरफोर्ड के बाद समरफील्ड आए, समरफील्ड के बाद बोहर आए, बोहर के बाद हीजनबर्ग आए, हीजनबर्ग, डी ब्रोगली, तमाम सारे लोग आए. And they keep on observing and they keep on telling, they keep on observing and they keep on correcting. So जितने लंबे समय तक हम ऑब्जर्वेशन करेंगे हमारे करेक्ट होने की गुंजाइश उतनी ज्यादा हो जाएगी. लेकिन कभी भी इतनी ज्यादा नहीं होगी कि हम नेचर को हरा दें या हम कोई नई चीज बना दें जो नेचर में नहीं उपस्थित है, क्योंकि सारा कुछ हमारा एग्जिस्टेंस ही किस पर है? नेचर पर. ठीक, ओके. अच्छा, मैग्नस कार्लसन नॉर्वे से हैं. सॉरी, उनका देश मैं भूल गया. सॉरी, कोई कह रहा है मैग्नस कार्लसन नॉर्वे से हैं, मुझे रसिया याद था. सॉरी फॉर दैट. चलिए आगे बढ़े. रमन कह रहे हैं हम लोग आज तक स्त्री को पूरी तरह नहीं समझ पाए, नेचर तो बहुत बड़ा. अरे स्त्री नेचर का प्रतीक है बेटा, इसीलिए नहीं समझ पाए. वो भी साइंस है, मेटाफिजिक्स कहते हैं उसे. योर यूनिवर्स स्टार्ट्स फ्रॉम योर मदर, तो तुम उसका बाई प्रोडक्ट हो भाई. हाउ कैन यू अंडरस्टैंड? जिस जगह से तुम पैदा हुए हो उसी को कैसे समझ सकते हो? ठीक है, दैट इज वाई द रीजन कि स्त्री को नहीं समझ पाए. स्त्री को इसीलिए नहीं समझ पाए कि नारी, स्त्री, विमेन, शी इज बेसिकली द ओरिजिन ऑफ दिस योर यूनिवर्स. हर किसी का अलग अलग यूनिवर्स है ना, मल्टी यूनिवर्स का कंसेप्ट है, तमाम सारी वो मेटाफिजिक्स है, इसलिए कहा गया. वो फिजिक्स इज, फिजिक्स तो गरीबों के लिए है, हमारे तुम्हारे जैसे लोगों के लिए, कम दिमाग के लोगों के लिए फिजिक्स है. जिनका दिमाग जागृत हो चुका है, जो बुद्ध हो चुके हैं, जो जैन हो चुके हैं, महावीर जैन हो चुके हैं, जो ईसा मसीह हो चुके हैं, जो मोहम्मद साहब हो चुके हैं, जो गुरु नानक जी हो चुके हैं, उनके लिए मेटाफिजिक्स है, उनके लिए ये फिजिक्स बहुत मजाक सी बात है। तो उन्होंने कहा स्त्री को नहीं समझ पाया, दैट इज मेटाफिजिक्स। वो भी यही बात कह रहे हैं, स्त्री मीन्स नेचर, जहां से सब कुछ पैदा हो रहा है, जहां से सब चीज की उत्पत्ति हो रही है। अबे तुम उसको समझ पाओगे? बच्चे हो, हम उसको समझ पाएंगे? बच्चे हैं, हमारी औकात नहीं है। लेट्स गो फॉर, आगे चलते हैं। So matter is made up these tiny particles and they are known as atoms. अच्छा, अब छोड़ते हैं इस डिस्कशन को, आगे चलते हैं। जस्ट लाइक ह्यूमन काइंड built Titanic and announced it as an indestructible challenging nature, but it's आइए, सो लेट्स टॉक अबाउट सब एटॉमिक पार्टिकल। रिसर्च आगे प्रोसीड की, और रिसर्च जब आगे प्रोसीड की तो हमें पता चला कि एटम के अंदर भी कुछ पार्टिकल्स होते हैं। Although there are several types of particles available in the atom, but we are focusing ourselves only up to 3 fundamental particles. They are sufficient to study our subject. So the first one is electrons. Electrons, negatively charged particle. Negatively charged particle. Negatively charged particle. Electron is negatively charged particle. The charge on electron is minus 1.6 into 10 to the power minus 19 coulomb, and it has very light weight, very low mass, 9.1 into 10 raised power minus 31 kilogram. This is the first particle. The second particle which we are having, that is known as proton. The second particle we are having, that is proton. It is positively charged particle. Positively charged particle. Positively charged particle. इस पर जो चार्ज है, that is plus 1.6 into 10 to the power minus 19 coulomb. It is quite heavier as comparison to the electron, almost 1850 times heavier as comparison to the electron. 1836 कई किताबें लिखती हैं. Some of the books used to write one proton is 1836 times higher than the one electron. Let us assume it 1850 because we are not exactly studying. So this mass of this proton is 1.67 into 10 to the power minus 27 kilogram. And then we have the third particle, and the third particle is known as neutron. These are the fundamental particles we have in the atoms. They are known as subatomic particles. These neutrons are electrically neutral particle. Electrically neutral particle. Electrically neutral particle. Electrically neutral particle. Charge on the electron is 0. The charge is 0. And mass on the electron is 1.67 into 10 to the power minus 27 kilogram. This is the mass, right? Although neutron is slightly heavier as comparison to the proton, but more or less both are same, having same mass, so you can write the equal value. When you read physics, you would be taught one thing, कि charge on any body is always an integral multiple of electron charge. Means एक इलेक्ट्रॉन के बराबर, 2 के बराबर, 3 के बराबर या 4 के बराबर. You will always get charge in the quantized form. It is always an integral multiple of electron charge. So the fundamental charge which we are having, that is the magnitude of electron charge. Any body can have charge in the multiple of that magnitude of electronic charge, either plus or minus, that's another thing, but the magnitude will always be an integral multiple of that charge. So in this subject we would be requiring several places the magnitude of charge. So let us take an assumption. Magnitude of electron charge whenever I write a small q in the subject, by default it means 1.6 into 10 to the power minus 19 coulomb. Some of the books used to write it with small e also, although I would be taking this notation in our analysis. So a small q means 1.6 into 10 raised power minus 19 coulomb. For the positive charge, you would be writing plus q, and for the negative charge you would be writing minus q. Sign would be getting given separately, magnitude means q, right? So you please write down this quickly, जल्दी से इसे लिख लें, फिर हम आगे चलते हैं. Subatomic particles. सौर्य कुमार सिंह जी कह रहे हैं कि सर पीडीएफ अवेलेबल है. नहीं बेटा, मेरे पास तो नहीं अवेलेबल है और पीडीएफ नहीं मिल पाएंगी नोट्स की. मैं यही सलाह दूंगा कि साथ में बनाते रहिए. Moyanger is asking, sir, can you give the names of discoverer? Although not required the discoverer of these particles, but electron was discovered by Sir J.J. Thomson. Proton, there is a controversy, but Goldstein is given the credit. Although Goldstein was Rutherford's student, so sometimes people used to say that Rutherford has discovered, but Rutherford or Goldstein, whatever name you get, you can go for the proton. And for the neutrons, you will be getting the name of Chadwick. Chadwick discovered neutrons. Although these are not required, names of these scientists are not required here. Let's go for the further discussion. Things got developed over the period of time, and in 1900, in the beginning of 1900, a scientist came named as Thomson, Sir J.J. Thomson, and Thomson has given his model that is known as Thomson's atomic model. Thomson said that the atom is a positively charged sphere. Atom is a spherical body in which positive charge and mass is uniformly distributed. Although this model is not now accepted, but still we need to know what he said and what kind of conclusion can be drawn from his model. So Thomson said that says that positive charge and mass is uniformly distributed in a spherical volume, uniformly distributed in a spherical volume, right? Just like a watermelon. Sometimes this model is also known as plum pudding model because of the similarity from the watermelon. अरे बेटा ये सब कैसे मेजर किया गया? सद्दाम हुसैन इज आस्किंग सर हाउ द वेट ऑफ इलेक्ट्रॉन इज मेजर्ड. इसके लिए एनसीईआरटी उठाओ. देयर इज अ मिल्कन-सायल ड्रॉप मॉडल एंड विद द हेल्प ऑफ व्हिच ही फर्स्ट कैलकुलेटेड E by M ratio, and from that E by M ratio he got to know the charge of electron and mass of electron. So for that please go for the NCERT books. There all the experiments are written over there. But here as I told you, we are not going to study the whole physics, right? I would be teaching only those points which would be required to study the material science. So I am not going into the depth of the each and everything. So I am taking the gist of the things. Right, come back to this. So positive charge and mass is uniformly distributed in a spherical volume. He said that the electrons which are negatively charged particles, they are embedded in this sphere in such a number so that overall atom remain electrically neutral. So electrons are embedded into it in such a number so that overall atom remain electrically neutral. Overall atom remain electrically neutral. Electrons are embedded into it in such a number so that overall atom remain electrically neutral. अब हमें पता चल चुका है कि ये बहुत ही बकवास मॉडल था, क्योंकि इलेक्ट्रॉन embedded नहीं होते. Embedded मतलब धंसे हुए. Instead they keep on moving. We know all those things. But at that time he told that कि this atom is a spherical body in which positive charge and mass is uniformly distributed, and electrons, which are negative particles, they are embedded into it in such a number so that overall atom remains electrically neutral. John Dalton got Nobel Prize. तो क्या एक गलत मॉडल देने के लिए? नहीं. He got credit for the discovery of a particle inside the atom, and that particle is known as electron. So credit of discovery of electron goes to Sir John Dalton. Apart from this, he told one more important thing, and that is the atom is electrically neutral. This is very important, because anything will remain stable only if it is neutral. This marker, this pen is stable only if it is neutral. Suppose it is having positive charge, then it will try to attract any negative thing from the environment, and it will try to make a new compound. It will not remain this pencil. Suppose it has negative charge, so it will try to attract any positive charge from the environment, and it will try to make a new compound. It will not remain pencil. So in order to remain pencil, it should be electrically neutral. Since it is made of the atoms, so if the basic unit with which it is made, that is electrically neutral, then the whole structure will remain neutral. So the man is giving one big explanation that the things are stable because they are electrically neutral, and they are neutral since the basic constituent with which they are made up of, that is neutral, and that basic constituent is atom. So this was the big thing which we can take from the Thomson's model, and that big thing is कि atom is electrically neutral. Atom is electrically neutral. The big implication of this model is atom is electrically neutral. Electrically neutral. Atom is electrically neutral. बस इतना ही थॉमसन्स मॉडल के बारे में बताऊंगा. जल्दी से लिख लें, उसके बाद आई वुड बी गोइंग फॉर द नेक्स्ट मॉडल क्विकली. चले आगे चले सर 2024 में रेलवे ईएससी में आने वाला है क्या? शायद नहीं, अभी कुछ भी ऑफिशियल नहीं है तो कुछ कह नहीं सकते। हाँ, ये ज़रूर है कि टेक्निकल पेपर कराने के बारे में सोच रहे हैं। अब वो सिविल सर्विसेज में ही टेक्निकल कराएंगे या ईएससी में कराएंगे, इसका कुछ अभी पता नहीं चला है। बट हाँ, कुछ प्रॉब्लम ज़रूर हुई है। जो आईआरएमएस का रिक्रूटमेंट था जिस तरह से, उस मोड में तो नहीं होगा ऐसा प्रतीत हो रहा है। बट एग्जैक्टली क्या फॉर्मेट होगा अभी कुछ नहीं कहा जा सकता है। जो भी होगा टेक्निकल पेपर कराने की सोचा जा रहा, और अगर टेक्निकल पेपर होगा तो कोई भी नाम दे दें एग्जामिनेशन का, उसमें जीत तो आपकी ही होगी क्योंकि पढ़ तो टेक्निकल आप ही रहे हो। ठीक, लेट्स गो फॉर द नेक्स्ट। थॉमसन ने एक बड़ी बात की। थॉमसन talked about the neutrality of the atom, but he made a mistake. He is saying that कि positive charge and mass is uniformly distributed. So to establish this fact कि whether the positive charge and mass is uniformly distributed or not, a man came and he did a very famous experiment. The man is named as Ernest Rutherford, and the experiment is known as alpha particle scattering experiment. Rutherford did this experiment to prove the validity of the statement given by John Dalton, and that statement is that mass is uniformly distributed. Yep, positive charge is uniformly distributed. To prove this thing, he did an experiment, and that experiment is known as alpha particle scattering experiment. On the basis of alpha particle scattering experiment, Rutherford proposed a new model of atom, and that is known as nuclear model of atom, and from there the modern concept of atomic model starts, which still revolve around a nucleus. So the beginning of the nuclear model of atom is after the alpha particle scattering experiment by Rutherford. So let's go for that experiment and let us see how did he perform that experiment and what was the conclusion. So Rutherford's atomic model. Rutherford's atomic model. Yeah, Rutherford's nuclear model of atom. Gautam Singh is saying, sir, this course is for GATE also. Dear Gautam, this subject, in the very beginning I told that this subject is not in the syllabus of GATE. It is only in the syllabus of engineering services. So if you are preparing for GATE only, then you can leave the class. This is not beneficial for you. First of all, you should know what is alpha particle. Alpha particle consists of two protons and two neutrons. This consists of two protons and two neutrons. So mass is very high. Mass, एक प्रोटॉन का मास 1 mu होता है, एक न्यूट्रॉन का भी 1 mu. So mass is 4 mu. Heavy particle. It is heavy particle. And you see, my dear friend, two protons means positively charged particle, positively charged particle, right? Why he took this particle? The reason was very clear. Mr. Thomson is saying that the positive charge and mass is uniformly distributed. So if it is like so, positive charge and mass is uniformly distributed, then if any alpha particle go, so this positive charge will repel and it will return back like this. Let us suppose there is no positive charge, only mass. So even if there is mass uniformly distributed, this will go and strike and then return back. if it happens like this, it means the positive charge and mass is uniformly distributed. But if it does not happen like this, it means there is some problem in the explanation of Thomson. So you need to modify that explanation. So this is the reason why he took alpha particles. Mr. Rutherford took a very thin foil of gold. Foil means sheet. So he took a very thin foil of gold, very thin. Why he took gold? Actually, gold is the most malleable material. Malleable means the material which can be converted into thin sheets by applying pressure. So it can be converted into the thinnest possible sheet. That's why he took the gold. Actually, the idea was to make it as thin as possible. In reality, in ideality, he is wanting to make it thin of one atomic distance. Although that's not practically possible, but the idea was like that. So he made a very thin sheet of gold, thin foil of gold, thin gold foil. And this was bombarded by the alpha particles. Series of particle is known as ray. So alpha particles was bombarded on this. ये alpha rays किसी source से. He was surprised. Why he was surprised? The reason behind is most of these rays traveled like this. With slight deflection, they crossed the material. With slight deflection, they crossed the material. Very few of these rays return back with few angle, with near about angle 180 degree. Why you need to be surprised? Because if the mass is uniformly distributed, then this should not cross. Instead, this should return. But only very few rays are returning back. It means mass is not uniformly distributed. Instead, it is concentrated into a very small region. The place from where mass is concentrated, the ray is hitting to that mass and returning back. Yeah, the place where positive charge is concentrated, the ray is being repelled back from there. So mass, a positive charge is concentrated into a very small region. It cannot be distributed. And since the rays are passing, most of the rays are passing through the material, it means most of the space of the atom is empty. Then only it is allowing to pass the rays. So he concluded that most of the portion, most of the region of the atom is an empty state. ज़रूरत हो तो स्कूटी भी खाली है, स्कूटी वहाँ रखी हुई है और उसकी चाबी, उसको यार पहुँचवा भी दो किसी तरह से, वहीं लगी हुई है, ठीक है. So the most of the positive charge and mass is concentrated into the small region, and most of the space is empty. That's why these rays are able to cross. But one more thing you need to observe. These rays are slightly deflected away. If they would have gone straight, then we could have concluded that empty space is there and they are going straight. But since they are deflecting away, it means from this point at some distance there is some negative charge, and that negative charge is attracting to these alpha particles which are positive, and that's why they are getting deflected. So Mr. Rutherford concluded that electrons, which are negative particles, they are far away from the atoms. So on the basis of this experiment, he concluded few things, and those conclusions were written as Rutherford's nuclear model of atom. I am giving you that conclusion, what he concluded. He said that the positive charge and most of the mass of atom is concentrated into a very small region, P for proton and N for neutron, right? This small region he named as nucleus. इस स्मॉल रीजन को उसने नाम दिया न्यूक्लियस. And he said that the electrons which are negative particles, let us suppose this is electron, right? This is electron, and this electron is negative particle. They are moving around the nucleus in some circular path with a very high speed. They are moving around the nucleus in some circular path with a very high speed. The place between the nucleus and electron, this is the empty space, and with this empty state the rays are passing through. But if they strike this, they will return back, and they are deflecting back because when they pass from here the positive charge will attract, so they are deflecting away. लोगों ने कहा everything is right, but how are you concluding that कि the electrons are revolving? Maybe they are static over there. So how can you conclude that they are revolving in a circular path around the nucleus? This man smiled and gave a beautiful answer. What is that answer? Have a look. He said that I am explaining why I am saying that electrons are revolving around the nucleus. Till then, Kepler has given 3 laws for the planetary motion of the planet, solar system के लिए. And those were the established thing, those were the well established laws. So he used the Kepler's laws to explain this. He said that the physics, till then the established physics, classical physics says that this is sun, right? Let us suppose the mass of sun is m1, and suppose there is a planet, this is a planet, suppose Earth, any planet, right? So I am taking the mass of this planet m2. Kepler-Bicep says that both of these are r distance away. So this sun is applying a gravitational force, and that force is actually directly proportional to the mass of sun and mass of planet ka product and distance ka square. This is the force. And since a force is working on the planet, so because of this force, this planet is moving into a circular path, and that path is known as orbit. So this was well established physics till then. The sun is applying a force on this planet, and because of that force, this planet is revolving around the sun. This is known as planet, solar system, yeah, whatever you say. Now you come. How beautiful explanation this man gave. I'm fan of this man. What a wonderful explanation he has established here. He is saying that this is a nucleus, and in the nucleus there are some positive charges. So let us suppose the charge is Q1. ये जो न्यूक्लियस है इसका चार्ज हमने Q1 मान लिया, ठीक है. मास एंड चार्ज बोथ आर द फिजिकल क्वांटिटीज. किसी ने अभी पूछा था कि मास को कैसे डिफाइन करें. फिजिकल क्वांटिटीज को जो फंडामेंटल उनको डिफाइन करना मुश्किल है, उनको सेंस करना पड़ता है, फील करना पड़ता है, ठीक है. तो चार्ज एक फंडामेंटल क्वांटिटी है, मास एक फंडामेंटल क्वांटिटी है. इन्हें सेंस करना होगा, हमारी इंद्रियां इन्हें सेंस करेंगी, उनको डिफाइन करना प्रॉपर्ली मुश्किल है. तो the charge is similarly fundamental as the mass, and this electron is another charge. Let us suppose it has Q2, and both of these charges are separated by certain distance, let us suppose r. So this nucleus will apply a attraction force on this electron, and according to Coulomb, this force is given by Q1 Q2 upon r square. It is proportional. एक proportionality constant आएगा, Q1 Q2 upon r square. Isn't the forces same? Both of these forces are identical. ये दोनों force एक जैसे हैं. You see, Q1 a physical quantity, M1 a physical quantity, Q2 a physical quantity, M2 a physical quantity, R the distance between these two quantities. So both of these forces are exactly same. And if the forces are same, then the motion of this object, that is electron, must be same as the motion of the planet. And that's why he said that the electrons are revolving around the nucleus, just like planets are revolving around the sun. This man goes one step beyond. He says that actually atom is nothing, it is doing the mimicry of the solar system, it is mimicking the solar system. It is actually the miniature version of the solar system, where the sun, role of sun is being played by the nucleus and role of the planet is being played by the electron. तो ये कुछ और नहीं है, जो सोलर सिस्टम है उसी का मिनिएचर स्केल है. A few moments before I was talking about metaphysics. What is the source of this earth and all those things, all the activities which is happening on the earth? That source is sun. Sun is the source of all the energy which is happening on our planet. So this is the ultimate source of energy, supreme source of energy. And because of that energy, we are getting energy at the planet, and every activity is happening at the planet. So everything which is at this planet, that is actually the part of sun's energy. So we are nothing but the miniature scale solar system. वही चीज कहना चाह रहा है. शायद इसने शंकराचार्य को पढ़ा होगा, क्योंकि शंकराचार्य इसी बात को कहते हैं अद्वैतवाद, मोनोथीज्म. He says that aham brahmasmi, मैं ही ब्रह्म हूं, means the ultimate source of energy, which he is saying God, and we are not the two different things. Instead, both of us are the same. We are the miniature scale of that ultimate source of energy. Same thing, this man Rutherford is also saying that the ultimate source, that is the solar system, and the atom with which we are made of, both are not the different, both are the same things. We are actually just mimicking that. So physics and metaphysics go hand in hand. Actually physics is nothing but the philosophy. Physics कुछ और नहीं है, ये philosophy है, दर्शन है. अब वो समझने का लेवल अलग अलग होता है दर्शन का. ठीक. So आइए, this man gives so beautiful explanation, and the nuclear model of Rutherford was accepted wholeheartedly by the everyone. But there was a man who could not accept it, and this man was named as Maxwell. Maxwell had some laws of classical physics, and during defining those laws, Maxwell says that if any charged particle is in motion, it should emit radiation. Radiation means energy. मैक्सवेल भाई सब कह रहे हैं कि अगर कोई चार्ज मोशन में है तो उसको रेडिएशन इमिट करना चाहिए. रेडिएशन मतलब एनर्जी. You see, my dear friend, here the electron, that is a charge, and that charge is in motion, so it should emit radiation. आप कहोगे कर लेने दो, क्या फर्क पड़ता है? नहीं पड़ता है. If this charge will emit radiation, means it is emitting energy, तो इसकी एनर्जी कम होगी. और अगर इसकी एनर्जी कम होगी तो घटते घटते इसकी एनर्जी एक सिचुएशन आ सकती है कि इट में कोलैप्स इनटू द न्यूक्लियस. सो दिस इलेक्ट्रॉन शुड कोलैप्स इनटू द न्यूक्लियस. कोई कहेगा ये बात प्लैनेट के लिए क्यों नहीं कह रहे हो? जी नहीं, प्लैनेट्स आर न्यूट्रल बॉडी, and for neutral body Maxwell has not given any law. He is saying that if a charged particle is in motion, then it should emit radiation. Planet is not a charged particle, it is as a whole a neutral body. So this Maxwell's law is not applicable for the planet. It is applicable, but it is applicable for the charge. So according to Maxwell, when this electron, which is a charge that is in motion, and if it is in motion, it should emit radiation. And if the electron is emitting radiation, then धीरे धीरे इसकी एनर्जी कम होती चली जाएगी, and it should collapse into the nucleus. भाई सुबह आपके पास बड़ी एनर्जी है, you start walking, you start running, you keep on running, you keep on running. As you keep on running, your energy will keep on draining. There will come a moment when you will lost all your energy and you will collapse. Same thing should happen with this electron. This electron keep on moving, keep on moving, keep on moving, and it is losing its energy, and when it is losing its energy, it should collapse into the nucleus. लोगों ने कहा हो सकता है कर रहा हो, एनर्जी रिलीज बड़ा स्लो रेट में हो रही हो, और अगर एनर्जी स्लो रेट में रिलीज हो रही होगी तो हो सकता है आफ्टर लॉन्ग टाइम इट शुड कोलैप्स इनटू द न्यूक्लियस। देन मैथमेटिकल कैलकुलेशंस बन रन कि आफ्टर हाउ मच टाइम द इलेक्ट्रॉन शुड कोलैप्स इनटू द न्यूक्लियस। वी गॉट सरप्राइज्ड, within a 10 nanosecond the electron should collapse into the nucleus। 10 नैनोसेकंड के अंदर it should collapse into the nucleus। so ये थ्योरी तो बिल्कुल बोगस है कि maybe it is drifting towards the nucleus over the long period of time it may collapse into the nucleus। that's not happening, it should collapse into 10 nanosecond। 10 nanosecond means मेरे पलक झपकते। अब तक तो ये जो हमने पेंसिल पकड़ रखा है इसके जितने भी इलेक्ट्रॉन थे वो न्यूक्लियस में गिर जाते। आप में से कोई बुद्धिमान व्यक्ति ये कहेगा, someone of you may say that maybe it is collapsing into the nucleus but we are not able to figure it out। and what happens if it collapses into the nucleus? why are you bothering about the collapsing of the electron into the nucleus? है तो एटम के अंदर ही ना जी, गिर जाने दो। अरे नहीं भाई साहब, तब आप भयानक मूर्ख हैं। यदि आपको ये लगता है कि इलेक्ट्रॉन न्यूक्लियस में गिर जाने से क्या होगा, गिरने दो, गिर रहा होगा, ठीक है, देन आप उच्च कोटि के मूर्ख हैं। क्यों? उसका कारण है, if electron is collapsing into the nucleus then what is happening? the distance between the two charges will become zero। ये r क्या हो जाएगा? जीरो, और ये r जीरो ही होते ही ये फोर्स क्या हो जाएगा? इंफिनिटी। as soon as an electron collapse into the nucleus infinite force would result। हर किसी बॉडी की एक अपर लिमिट तक फोर्स बर्दाश्त करने की क्षमता है। एवरी बॉडी हैज एन अपर लिमिट टू विथस्टैंड अ सर्टेन फोर्स। आई एम टेकिंग दिस पेंसिल, इफ इलेक्ट्रॉन वुड हैव कोलैप्स्ड इनटू द न्यूक्लियस देन इनफाइनाइट फोर्स वुड हैव बीन जनरेटेड। I may not be able to handle that force। उस फोर्स की वजह से इतना बड़ा विस्फोट होता कि हम और आप दोनों खत्म हो गए होते। आप कहते कि मैं तो बहुत दूर बैठा हूं, अरे इनफाइनाइट फोर्स है, पूरा ब्रह्मांड ही खत्म हो जाएगा। Everything will collapse। It means electron is not falling into the nucleus। And if the electron is not falling into the nucleus, so either Rutherford is wrong or Maxwell is wrong, or both are correct but they are not able to explain how the things are happening। So stability of atom is there, that is for sure, because everything is stable। this is in my hand, so atom is stable, means electron is not collapsing। but Rutherford and Maxwell both are not able to explain why the atom is stable। and that was the reason why Bohr came into the picture, and that was the reason Rutherford's model failed। he could not explain about the stability of atom, so his model failed and Bohr came into the picture। Bohr can be considered the founding father of the modern physics। he is the first man who talked about the things which on the basis of which the modern physics, the foundation of the modern physics is laid down। so I would be talking about the Bohr's model in depth, but before that Rutherford के सम्मान में दो चार लाइनें लिख लेते हैं। तो मैं बोर्ड पर लिखूंगा नहीं, मैं डिक्टेट करूंगा, आप लिखिएगा। मैं चेयर पर बैठ करके थोड़ा सा डिक्टेट करता हूं और आप लिखने की कोशिश करिए। सो लेट्स ट्राई टू राइट Rutherford's मॉडल। इसमें कुछ बनाने की जरूरत तो है नहीं, अभी कुछ लिखा है नहीं, दो चार लाइनें रदरफोर्ड के सम्मान में। बात करेंगे हिमेश जी अभी कि इलेक्ट्रॉन क्यों नहीं एनर्जी रिलीज कर रहा। वो स्ट्रिंग थ्योरी हो रही तो बाद में आई, अभी बोहर चाचा बताएंगे आपको कि ऐसा क्यों हुआ। नहीं बेटा प्रवीण, बेटा गलत सोच रहे हो। कहां से थॉमसन हो जाएंगे? थॉमसन में पॉजिटिव चार्ज इज यूनिफॉर्मली डिस्ट्रीब्यूटेड तो उस पूरे डिस्ट्रीब्यूशन का सेंटर जब देखोगे तो वो स्फीयर का सेंटर आएगा, और इलेक्ट्रॉन स्फीयर के सेंटर पर नहीं है, इट इज एम्बेडेड हियर एंड देयर. So net positive charge, if you net distance if you see between positive and negative charge, that's not zero, that is some distance even in the Thomson's model. आप गलत सोच रहे हैं, आप किसी पर्टिकुलर जगह पर जहां जितना चार्ज है उसी की बात कर रहे हैं. Net positive and negative, you see here all the electrons should be collapsing into the nucleus, so net negative charge and net positive charge इन दोनों के बीच की डिस्टेंस जीरो होनी चाहिए, ठीक, जो कि थॉमसन मॉडल में नहीं हो रहा है. होप यू गॉट माई पॉइंट. चलिए लिखते हैं. प्लीज स्टार्ट राइटिंग फ्यू थिंग्स. थॉमसन भाई साहब के मॉडल के बारे में एक दो बातें लिखा जाए. First point, on the basis of, start writing Rutherford's model, not Thomson, sorry, Rutherford's model. On the basis of his famous, on the basis of his famous alpha particle scattering experiment, alpha particle scattering experiment, on the basis of alpha particle scattering experiment, alpha particle scattering experiment, Rutherford proposed the nuclear model of atom, the nuclear model of atom. On the basis of alpha particle scattering experiment, Rutherford proposed the nuclear model of atom. According to this model, according to this model, according to this model, डैश लगाएं, फर्स्ट पॉइंट लिखें. according to this model, डैश लगा, फर्स्ट पॉइंट, the positive charge and the positive charge and the positive charge and most of the mass of atom, most of the mass of an atom the positive charge and most of the mass of an atom is concentrated concentrated in extremely small region, in extremely small region. This small portion of atom was named as, this small portion of atom was named as nucleus. This small portion of atom was named as nucleus. Nucleus, full stop. Next point. In the first point, I told you the positive charge and most of the mass of atom is concentrated in a very small region. this very small portion of atom was named as nucleus. Next point, second point, the nucleus is surrounded by electrons. The nucleus is surrounded by electrons. The nucleus is surrounded by electrons, surrounded by electrons that move around the nucleus that move around the nucleus that move around the nucleus move around the nucleus with a very high speed, with a very high speed in circular path, in circular path called orbits, called orbits. Called orbits. The nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called orbits. Full stop. Thus Rutherford's model resembles resembles the solar system in which nucleus plays the role of sun, in which nucleus plays the role of sun, and the electrons that of revolving planets, and the electrons that of revolving planets. Rutherford's model resembles the solar system in which the nucleus plays the role of sun and the electrons that of revolving planets. Full stop. Third point लिखें. Electrons and nucleus are held together. Electrons and nucleus are held together. Electrons and nucleus are held together by electrostatic force of attraction. By electrostatic force of attraction. Third point, electrons and nucleus are held together by electrostatic force of attraction. So this was about Rutherford's model. I am not going to be in the nitty-gritties what Maxwell told and all those things, not required. Just Rutherford के सम्मान में few lines related with the Rutherford model we discussed. एक अखिलेश गुप्ता जी हैं, बड़ा मजाक सा क्वेश्चन किया इन्होंने कहा कि alpha particles, atom and its properties, how come was discovered till then when nothing was explained till then. अजीब बात करते हो, ऑब्जर्वेशन नहीं है, ठीक है. कभी दूध गर्म करते देखा है घर में महिलाओं को, या आपकी माताजी, सिस्टर, या आपने कभी दूध गर्म किया हो, ठीक है. जब आप दूध बॉयल कर रहे होते हैं तो वो जब ऊपर आने लगता है तो उसमें फट से क्या कर देते हैं, चम्मच डाल देते हैं. ऐसा क्यों करते हैं? पूछो अपनी माताजी से, तो बोलेंगी कि इससे जो दूध उफन करके गिर रहा होता है वो बंद हो जाता है. नहीं गिरता है। अब मुझसे पूछो तो मैं बताऊंगा कि जैसे ही किसी मटेरियल में कोई इंप्योरिटी ऐड करते हैं उसका बॉइलिंग पॉइंट बढ़ जाता है, और बॉइलिंग पॉइंट बढ़ जाता है तो वो जो वेपराइज होने जा रहा था वो वेपराइज नहीं होता बल्कि सेटल डाउन हो जाता है। अब उसको और टेम्परेचर चाहिए वेपराइज होने के लिए, लेकिन आपकी माता जी को ये नहीं पता है। बट एक्सपेरिमेंट तो उन्होंने किया है ना, तो एक्सपेरिमेंटली तो उन्हें चीजें पता है, एक्सप्लेनेशन बाद में दिया। एक्सप्लेनेशन आप पढ़ करके दिए कि माता जी जब चम्मच आपने डाला तो उसकी वजह से बॉइलिंग पॉइंट बढ़ गया। तो एक्सप्लेनेशंस बाद में आई। इसका मतलब ये नहीं कि एक्सपेरिमेंट नहीं किए जा सकते थे, चीजें नहीं थी, ये तो सदियों से होता चला आ रहा है। आपके घर में कब से, आप जब से छोटे रहे होंगे ना, तब से माता जी दूध जब गर्म की होंगी तो उसमें चम्मच डाल दी होंगी, और शायद उन्हें आज भी नहीं पता होगा कि क्यों चम्मच डाला उन्होंने। ये बॉइलिंग पॉइंट का कंसेप्ट नहीं पता होगा, बट कर रही है ना। ठीक वही एक्सप्लेनेशन यहां पर भी है। ठीक है, एक्सप्लेनेशंस मे बी गिवन ऑन द लेटर ऑन स्टेजेस, बट इट डज नॉट मीन दैट कि एक्सपेरिमेंट्स कैन नॉट बी डन अर्लियर। चीजें तो पहले भी थी, तो एक्सपेरिमेंट्स वर डन अर्लियर। एक्चुअली अपूर्व रदरफोर्ड के ही स्टूडेंट थे गोल्डस्टीन, उनके अंडर में पीएचडी कर रहे थे। सो थोड़ा सा डिबेट है कि प्रोटॉन की डिस्कवरी का क्रेडिट रदरफोर्ड को दिया जाए या गोल्डस्टीन को दिया जाए, बट गोल्डस्टीन को ज़्यादा इंपॉर्टेंस मिलती है। बट कई जगहों पर रदरफोर्ड का भी नाम आता है क्योंकि उन्हीं के अंडर में पीएचडी कर रहे थे। आइए आगे चलते हैं। So these were the few limitations of the Rutherford model, and to overcome these limitations, a man came with a very high vision, and that man was named as Bohr. So let's go for the discussion of Bohr's atomic model. Bohr gave this model for the hydrogen atom. Let's see Bohr's atomic model. Bohr's model is based on some postulates, assumptions. अब बड़ी दिक्कत है कि सबसे पहले तो आपको assumption और postulate में अंतर समझ में आना। assumption या postulate और थ्योरी का अंतर पता होना चाहिए, नहीं तो आप बोहर को कभी समझ ही नहीं पाओगे। क्या है थ्योरी और postulate में डिफरेंस? किसी को पता है? Abru Bashir is saying कि why planet is of no charge. अरे बेटा, क्योंकि प्लानेट को एग्जिस्ट करना है, और कोई चीज स्टेबल तभी होगी जब इलेक्ट्रिकली न्यूट्रल होगी। तुम भी प्लानेट हो, एक न्यूट्रल हो। ठीक है, थोड़ी देर पहले मैंने बोला था आइसोलेटेड एग्जिस्टेंस उन्हीं चीजों का संभव है जो इलेक्ट्रिकली न्यूट्रल है। चलिए, अब्रू बसीर जी, धन्यवाद। आनंद शर्मा जी, अरे अखिलेश तुमको समझ में आया? नहीं आया, चुप बैठ गए। नहीं आया, और एग्जाम्पल है हमारे पास। डाउट को डाउट नहीं रहने देना, और मेरी किसी हुई बात को बुरा नहीं मानना है। ठीक है, मैं आपका दुश्मन नहीं हूं अगर मेरी कोई बात बुरी लगे तो। ठीक है, आई एम योर टीचर. My responsibility is to clear your doubts, to make you literate, to make you knowledgeable, right? So that's my responsibility. My responsibility is not to do the entertainment for you. उसके लिए तो आलिया भट्ट है, रणवीर सिंह है, रणवीर कपूर है. So they would be doing entertainment for you. I am to teach you, right? Let's come back. What is difference between assumption and theory? देखो, थियरी वो चीजें हैं जो एक्सपेरिमेंटली एंड मैथमेटिकली प्रूवन है. सो यू कैन डेराइव देम, यू कैन मैथमेटिकली डेराइव देम, यू कैन एक्सपेरिमेंटली प्रूव देम. लेकिन एजम्पशंस वो फंडामेंटल लॉज हैं जिनकी आप लॉजिकल एक्सप्लेनेशन तो दे सकते हो, बट इनका मैथमेटिकल प्रूफ मिसिंग होता है. These are the fundamental laws which can be logically proven, but mathematically they cannot be. द मैथमेटिकल एक्सप्लेनेशन इज मिसिंग, जबकि थ्योरी में मैथमेटिकल एक्सप्लेनेशन होगी। कैसे एक अंतर को समझते हैं? जैसे बचपन में जब 11th क्लास आपने पढ़ा होगा तो काफी लोगों ने पोस्टुलेट या स्टेट या एजम्पशन का अंतर मतलब थ्योरी का अंतर समझाया है। मेरे एंगल से देखिए, अच्छा है आपका एफर्ट अच्छा है, बहुत बढ़िया। बचपन में जब 11th या 12th क्लास आपने किसी भी बोर्ड से पढ़ा होगा तो वहाँ बूलियन अलजेब्रा फिजिक्स में इंट्रोड्यूस की जाती है और बड़ी एक खतरनाक सी चीज़ बता दी जाती है बूलियन अलजेब्रा में। हम तो पहली बार देखे, हमारा दिमाग ही खराब गया कि ये क्या मजाक चल रहा है, ऐसे कैसे। वहाँ हमको बताया जाता है 1 + 0 = 1 और फिर उसके नीचे लिखा जाएगा 1 + 1 = 1। मैथमेटिकली 2 होना चाहिए 1 + 1। बूलियन अलजेब्रा में भाई साहब कह रहे हैं कि नहीं जी, ये बेसिक पोस्टुलेट है, 1 + 0 भी 1 होता है और 1 + 1 भी 1 होता है। ये है एजम्पशन या पोस्टुलेट। इसी एजम्पशन पर पूरा का पूरा डिजिटल वर्ल्ड चलता है। द होल डिजिटल वर्ल्ड रन्स ऑन दिस एजम्पशन। So everything in the digital world is proven by accepting this fact, and this fact cannot be proven mathematically. Mathematically 1 + 1 should be 1, 1 + 1 should be 2. Mathematically you cannot prove, but every other thing you are proving by using this. Although logically you can prove it. How logically you can prove it? Let us have a look. Let us suppose here 1 is signifying that a switch is on. Let us suppose we have a system in which there are 2 switches, switch A and switch B, and we are connecting them parallelly, and we connect them with a battery, and this switch is connected with the bulb, and let us suppose we are having this some 5-volt battery, anywhere 5-10 volt, and this is the bulb. Here we are taking output, let us suppose Y, and these are the switches. So let us suppose 1 is logically indicating that switch is on, and 0 is logically indicating that switch is off. So 1 and 0 has some logical significance, not the mathematical. Similarly, Y = 1 means bulb glow कर रहा है, bulb glow, then we would be saying Y = 1, and if Y = 0 it means bulb does not glow. This had significance, does not glow. My dear friend, have 2 possibilities here. Let us suppose I close switch A but open switch B. So for A 1 but for B we are 0. So it is what? 1 + 0. Because of this 1 + 0, what will happen? The current will get this path and it will start flowing. This bulb will get current and it will glow. So since bulb is glowing, so Y = 1, right? So it is 1. So 1 + 0 became 1. Now my dear friend, let us have a different look. Suppose we take a case where A = 1, yani this switch is on, I on this switch also, and this B = 1. Still the current is going through this bulb. ऐसा तो हो नहीं जाएगा कि 2 करंट जाने लगे, ये शॉर्ट सर्किट हो जाएंगे, सेम करंट इज गोइंग थ्रू द बल्ब एंड बल्ब विल ग्लो. Y = 1. दोनों स्विच ऑन करने की वजह से यू आर नॉट गोइंग टू 2 bulb, you will have only the 1 bulb and that will glow itself, and glowing up bulb is indicated by 1. If does not glow, then it is indicated by 0. So even if you on both switches, still you are getting glowing up bulb, that is 1. That's why we say 1 + 1 = 1. Right? So logically we are able to prove it, but mathematically it's not correct. Mathematically 1 plus 1 should be equal to 2. Whereas we are saying that here 1 and 0 does not have mathematical significance. Instead, they have logical significance. Once you accept this, now the whole digital world is derived on these facts. On this basic postulate, we are doing everything in the digital. क्यों? इसी इलेक्ट्रिकल वालों तुम्हें तो पढ़ाया होगा किसी न किसी सेंटर पर, मैंने डिजिटल भी पढ़ाया होगा. So there I may have been starting with this point. Similarly, we are going to talk about few assumptions in the Bohr model. Bohr's atomic model is based upon three fundamental assumptions, three fundamental postulates. Those postulates cannot be mathematically proven, but they have logical proof. You accept those postulates, then several other things can be developed, but you do not have any mathematical proof for those postulates. इसीलिए बोहर्स की थ्योरी में आप देखोगे हमेशा लिखेगा बोहर्स एटॉमिक मॉडल इज बेस्ड अपॉन फॉलोइंग एजम्पशंस या बेस्ड अपॉन फॉलोइंग पोस्टुलेट्स. कभी कोई किताब नहीं लिखेगी कि बोहर गेव दिस थियरी एंड ऑल दैट. नो, बिकॉज बोहर हैज गेव सम लॉजिकल इंट्यूशनल एजम्पशंस. राइट, सो लेट अस सी व्हाट बोहर हैज गिवन. चलिए बात करते हैं बोहर ने क्या बात कही. होप यू अंडरस्टैंड द डिफरेंस बिटवीन द एक्सप्लेनेशन, डिफरेंस बिटवीन द assumption and theory. Yes, हिमेश, बहुत बढ़िया. Postulate is a statement that is accepted without proof. Assumption means we let something for doing. Theory means something happens on the basis of theory. चलिए ठीक है, काफ़ी लोगों ने अपने अपने एफर्ट किए हैं और बहुत अच्छा समझाया आप सभी लोगों ने. अच्छे लग रहे हो, बढ़िया स्टूडेंट लग रहे हो. सर पोस्टुलेट मतलब पहले उसकी थ्योरी दे के एक्सपेरिमेंट किया गया, बाद में प्रूव किया गया, ये भी कह सकते हो. बहुत बढ़िया. एवरीवन हैज़ डन वंडरफुल एफर्ट एंड एवरीवन इज गोइंग इन द सेम डायरेक्शन. लेट्स गो फॉर द बोहर्स मॉडल. सो बोहर गेव three fundamental assumptions. What were the three assumptions made by Bohr? First thing, Bohr is saying that the Rutherford's statement कि proton and neutron is concentrated into a small region, that is correct. So he is also accepting this thing. कि yes, there is a nucleus and in that nucleus positive and negative charges are concentrated. Positive charge and neutron is concentrated. Yani proton and neutron is concentrated into a small region that is known as nucleus. Now he is saying that electrons, which are negative particles, they revolve around this nucleus in some circular path of fixed radius. So they cannot revolve at every place. Instead, they are allowed to revolve in certain fixed positions. Some certain fixed circular orbits में ही इलेक्ट्रॉन रिवॉल्व कर सकते हैं. इसे मैं पहला ऑर्बिट मान लेता हूं, इसे मैं दूसरा ऑर्बिट मान लेता हूं, इसे मैं तीसरा ऑर्बिट मान लेता हूं, चौथा, लाइक दैट. यानी 0 से और 1 के बीच में इलेक्ट्रॉन कहीं पर भी नहीं हो सकता. Electron can be only at this place. Then 1 to 2 electron cannot occupy any place. It will be only at 2 or at 1. And 2 to 3 it cannot occupy any place. It will be only either at 2 or 3. So he is saying that electrons are not allowed to take all the positions around the nucleus. Instead, they can move in certain fixed positions, in certain fixed orbits. Good. People said that how will you find that at which place the electrons should move? How will you calculate the radius of that place where the electron is moving? So he said that electrons can move only in those orbits where angular momentum of electron is an integral multiple of h by 2 pi. MBR is known as angular momentum. So angular momentum of electron is an integral multiple of h by 2 pi. जिन जिन प्लेसेस पर ये बात सेटिस्फाई होगी, इलेक्ट्रॉन विल बी मूविंग ओनली इन दोज प्लेसेस. मीन्स for certain value of radius, this equation is satisfied. So it is satisfied for n is equal to 1, it is satisfied for n is equal to 2, it is satisfied for n is equal to 3, it is satisfied for n is equal to 4. So these are the places where electrons would be revolving. It is not satisfied for 1.2, it is not satisfied for 1.7, it is not satisfied for 2.8. n की वैल्यू मैं बात कर रहा हूं. So electron cannot occupy those places. So electrons are revolving only in those orbits where angular momentum is an integral multiple of h by 2 pi. Here n is an integer and its value starts from 1, so it is 1, 2, 3, 4 up to infinity. And h is known as Planck's constant. I would be talking about it in the later on stages of our subject. So it is Planck's constant. It has certain fixed value. M is mass of electron, V is velocity of electron, R is radius of electron. एक झटके में इस व्यक्ति ने बड़ी जबरदस्त बात कह दी. He said one very important thing in just one equation. My dear friend, if you see, let us suppose an electron is moving in this orbit, so radius r1. So at every place this radius is fixed, and if this radius is constant, then you can write mb is equal to nh by 2 pi r. So r is fixed because at every point in this orbit radius will remain same. Circle की radius same होती है हर point पर. And h is constant, n is equal to 1 for first orbit, that is also constant, so this value is constant. And if mb is constant, mb is nothing but momentum, and kinetic energy of any particle is half mb square, that is nothing but equal to p square by 2m, momentum by 2m. If momentum is constant, kinetic energy is constant. It means if an electron is revolving in a orbit, then its kinetic energy is same at every point in the orbit. If an electron is moving in an orbit, then its momentum is constant, means its kinetic energy is constant at every point in the orbit. रुक जाओ. Apart from kinetic energy, we will have one more energy that is known as potential energy. And potential energy will depend upon the distance. Basically, potential energy is what? Positional energy. So it will depend upon the distance of this positive and negative charge. But you see, my dear friend, in an orbit, the distance of this electron is same at every point from the nucleus. It means potential energy will also remain constant. So if I connect these two, then I am saying that if an electron is moving in an orbit, then its total energy is constant, because potential and kinetic energy both are not changing at any point in the orbit, so they are constant. And if the total energy is constant, then electron is not emitting any energy. So the man, means Bohr, is wanting to say that although electron is in motion around the nucleus, but when this electron is moving in a particular orbit, its energy is constant. It means it is not releasing any energy. ये किसी भी तरह की energy को release नहीं कर रहा. So these orbits are known as stationary states. कई लोग कंफ्यूज हो जाते हैं कि स्टेशनरी कैसे जी, इलेक्ट्रॉन तो मूव कर रहा. नो, स्टेशनरी विद रेस्पेक्ट टू एनर्जी means energy is constant, that's not changing with time. So when an electron is moving in an orbit, and if the energy is not changing, तो जो मैक्सवेल बात कह रहे थे वो खत्म हो गई. Forget about that. लोगों ने कहा लेकिन यार रेडिएशन तो होता है. लोगों ने एक्सपेरिमेंट किया है हाइड्रोजन के ऊपर. पीपल हैव डन एक्सपेरिमेंट ओवर द हाइड्रोजन. दे फाउंड दैट लाइमन सीरीज, बामर सीरीज, पास्चन सीरीज, फंड सीरीज, lots of kind of radiations are emitted from hydrogen. How does these radiations are happening? So Bohr is explaining that also. He is saying that actually the radiation happens when an electron makes transition from one orbit to the another orbit. Because if you see, if the energy for this orbit is even, then the radius of this orbit will change, and hence velocity of electron in this orbit will be different as comparison to this, as well as the distance of this charge is different as comparison to this. So potential and kinetic energy both will change. So here the energy will become E2, let us suppose. Here the energy will become E3. So if the electron is coming from E2 to E3, then it will emit radiation, and this radiation is nothing but delta E. Likewise, if an electron is going from lower to higher level, then it should absorb. So absorption should take place. So Bohr is saying that actually the people which we are getting confused by the radiation, this radiation is not happening because of the motion of electron in a particular orbit. Instead, the radiation happens when electron is making transition from one orbit to the another orbit. If electron is coming from higher orbit to the lower orbit, then difference of energy between these two orbits is released in the form of radiation. And if it is going from lower orbit to the higher orbit, then this difference of energy is absorbed. He gave one more beautiful thing. He said that this emission or absorption radiation frequency is directly proportional to the delta E. In fact, he said that delta E is equal to h nu, where delta E is difference of energy between the orbits in which electron is making transition. Electron is making transition. Difference of energy between the orbits in which electron is making transition. Means if it is going from 1 to 2, then difference of these energy. If it is going 3 to 2, then this difference of energy. If it is coming from 3 to 1, then that difference of energy. And nu is frequency of radiation. So these are the three beautiful things said by the Bohr, and this model is known as Bohr's atomic model. Although this model has its own problems, I will be discussing about the problems, what are the problems related with the Bohr's model and why it could not become the successful model. This model also failed, but this model gave certain beautiful explanations. One of those beautiful explanations is that the electron is not allowed to take any value of energy. Instead, it will take energy E1 or E2. No energy between E1 and E2 can be accepted by the electron. So energy of the electron around the nucleus is not continuous, it is quantized. So this concept of quantization of energy started to come into the picture from Bohr's model. So this man has given some revolutionary things. I will be talking about those things in the next class. But today, before wrapping up the class, let's write quickly about these 3 points of the Bohr's model. So I am dictating it, and please note down Bohr's model quickly so that लिखें जरा. Bohr's atomic model is based upon following assumptions. चलिए मैं लिखता चलता हूं साथ में. Bohr's atomic model is based on Bohr's atomic model is based on following assumptions. First assumption: the electron in the atom can move. The electron in the atom can move around the nucleus in a circular path around the nucleus in a circular path, in a circular path of fixed radius, in a circular path of fixed radius and energy, circular path of fixed radius and energy. These paths are called orbits. These paths are called orbits. Paths are called orbits. Stationary states, are allowed energy states, or allowed energy states. This is the first point said by this great man. The second assumption, the second one, he is saying that an electron can move only in those orbits, an electron can move only in those orbits, an electron can move only in those orbits for which its angular momentum is, its angular momentum is an integral multiple of h by 2 pi, for which its angular momentum is an integral multiple of h by 2 pi. That is why only certain fixed orbits are allowed. That is why only certain fixed orbits are allowed. In this I told you MBR is equal to NH by 2 pi. Regarding H, I would be discussing later. This N is an integer starting from 1, 2, 3, 4 up to so on. Let's go for the third statement by this man. Third statement is saying that when an electron jumps, from an orbit of higher energy, when an electron jumps from an orbit of higher energy to another orbit of lower energy, to another orbit of lower energy, then energy is released in the form of radiations. In the form of radiations, and vice versa. वाइस वर्सा का मतलब इफ लोअर टू हायर जा रहे हैं तो एब्जॉर्ब होगी, ठीक. द अमाउंट ऑफ एनर्जी रिलीज्ड आर एब्जॉर्ब्ड इज द अमाउंट ऑफ एनर्जी released or absorbed is the difference of energies difference of energies between the two orbits, between the two orbits. Mathematically, I told it delta E is equal to h nu, and these things has been explained earlier, right? So these were the three big statements given by Neil Bohr. I will be talking about this model in the next class as well. So we will begin this class from here onwards in the next class. Tomorrow at 9 AM we will start our discussion here onwards. यहीं से आगे हम लोग अपना डिस्कशन करना स्टार्ट करेंगे. आज के लिए बस इतना ही. आप सभी का आभार, धन्यवाद. Those who are having problem with Hindi and English in any of the language, if you are not comfortable with my way of delivery, so you can contact with the DG management, and if they instruct me to speak in Hindi, I will be speaking in Hindi in the future classes. And as of now, I have been given the instruction to speak in English, and that's why I'm continuing the whole explanation in English. Thank you. Have a wonderful time. Have a very pleasant day. Thank you very much. Akhilesh Gupta is writing, how come he gave such bold expression? Read some physics book there, the whole story behind this is given, right? Anukriti, yes, final year student can apply for engineering services. So 7th sem means final year, yes, you can apply. Thank you. I will be telling the technical team to record the lecture, to send the lecture as soon as possible. Don't worry.